So we just finished up with the 106th annual meeting of the National Shell Fisheries Association group. They had their annual conference in Jacksonville, and we just finished up. So I was able to tap into some of the expertise that some of the folks that were participating there. And we wanted to move on from Louisiana and Alabama, where we had speakers over the past several months talk about the systems that they're testing there in the Gulf of Mexico waters, and maybe talk about what's going. There's Clayton. Hey, how are you? And talk about what's going on in the Northeast, because that's an industry that has grown by leaps and bounds in terms of intensive oyster cultivation, and we wanted to see what's going on up there. So we could not have three better speakers today to give you that information. They've been in the industry for years. I think in one of the first flyers that I went out, I think I said here for over 20 years. I was quickly corrected, over 30 years. So I think if we add up the experience of all three speakers today, you might have close to 100 years of experience in this room. These are also very good friends of mine. We're going to start off with Dale Leavitt, and Dale's an associate professor at Roger Williams University, that's in Rhode Island, and he has, again, a long history of very hands-on practical experience, starting in Massachusetts with first Woods Hole Oceanographic Institution as a research associate, and then moving on with Sea Grant and the Cape Cod Cooperative Extension Program to work with the shellfish aquaculture industry that's very extensive out in the Cape Cod, participating in a wide range of aquaculture-related projects that include environmental impact studies, seawater system design and engineering. In fact, Dale and his private consulting company redid this saltwater system here 10 plus years ago.
10 plus years ago.
And now they need to have it fixed again, so the timing was perfect. Economic development activities, aquaculture education and training. Dale's done it on, very hands-on, very practical, and actually I think a couple of years ago he started a 12-week course on practical shellfish farming. That's the name of the course, in which all aspects of shellfish farming are covered, and it's not just for, and there's Mona, how are you? Nice to see you. So he is going to condense that 12-week course into 12 hours today for you. No. No.
So pull up your chair and sit around, gather around.
So let's get started. So I do think we want to turn these lights off. Paul, if you want to grab those real quick.
Actually, one slight correction. I've been teaching this course for about 20 years now.
Oh, really?
Yeah.
It's not, oh, okay. So it's,
Well, welcome, folks. As Leslie pulls up my few slides, just a few slides that I have for you today. I want to leave this as open as possible. I mean, I have a lot of slides to get through, so we can't take a lot of diversions, but at the same time, if I say anything that isn't clear, or you want more information, or you want to talk about it a little bit, don't hesitate to jump in. I've also invited my two conspirators, as well as Leslie, to if there's something that I'm saying that they want to emphasize or clarify or add to, then they're going to jump in as well. So what we're going to talk about today is I'm going to cover growing oysters the way we do it up in the Northeast, and I'm going to focus on a lot of the bottom and suspended culture. We're not going to talk about any of the oyster grow floating gear or the Australian longline system, because it sounds like your folks have been pretty well versed in that. So our normal production cycle in the Northeast, which is going to be considerably different from yours, because we have to run through at least one overwintering session to get our animals up to market size, and in some cases it actually takes us 2 winters and then into the spring before we can get our stuff up to market size, and we're pretty happy with that. If you look at the Canadian folks, they have to go through 3 to 4 and sometimes even 5 winters, so that their crop is a 5 to 6 year crop. Ours is a 2 to 3 year crop, and they've been pretty successful. Rhode Island last year doubled its farm gate value of oysters in 1 year, which is fairly impressive. So this is a slide that I stole from Leslie, but I didn't realize that she just yelled at me for putting it in my slideshow. What you need to do is a whole bunch of things you need to think about when you're getting ready to start farming oysters. And some of these things are things that you don't have any control over, like the physical characteristics of the site, but you certainly have to be aware of it, and you have to understand what's going on at your site, because that's going to dictate to a large degree both what you're going to grow there and also the sort of what technology you're going to use. And we're going to talk about technology today. Leasing and permitting is something that it's unique everywhere we go, so we usually try to stay away from that as much as we can. So we're going to talk about the American oyster, and most of oysters that we deal with up in the Northeast are hatchery produced, although I'm going to talk a little bit about some wild spat collection, which I think may have some application down here. Generally what we do is we start moving stuff out of our nursery systems anywhere from 3/4 to around 2 inches, depending on what your final grow out system is. And I have a couple of words of wisdom that I always give to my growers as they start out in this business. And handling oysters, as if you folks that are growing clams are probably well aware, it gets more complicated the smaller the animal you get. And so what we always try to do with our new oyster growers is to really push them to get as big a seed as they can afford to buy. Obviously, the bigger the seed, the more expensive it is. But the bigger the seed, the lower the risk in terms of being able to successfully grow them up to market size. And so as you figure out how to handle these things and how to grow them and what their differences are from other things that you may be used to growing, you can start looking at getting smaller and smaller animals and looking into maybe earlier stage grow out systems, or even start looking at developing your own nursery system. And the last thing for my new growers, I always throw in this word of wisdom, not to invest any more than you can afford to lose the first year, because there's always that risk that you're going to have some kind of catastrophic problem. So what technological options do I have? A lot of that's site specific. And so there are land-based systems, and for us, because we have some areas where we've got 8-foot tides, and so we have fairly extensive intertidal areas. So a lot of our oyster growing at least on the north side of Cape Cod and up into Maine is done intertidally. Although when you're working intertidally, then you've got to deal with issues of ice in the wintertime. Probably not going to be a big option for you guys down here. So you're going to be working primarily in the subtidal zone. Floating gear, I hear you've already had lots of information on, so we're going to pretty much ignore that for the most part. Suspended gear, we're going to talk a little bit, and then gear that's going to be on bottom, but maybe in a little bit deeper than just the shallow subtidal areas that we'll be talking about there. So this is a slide that I stole from Skid, and these are just some of the things that you have to think about up front. And the first thing is that site really is a huge factor in your success or failure with growing any shellfish, but certainly oysters. Physical factors, salinity, oxygen, food are all important. Biological factors, predation, disease are in fact equally as important. And you need to understand your site in order to really figure out what the best technology is for you. Because each site's unique. You can get data. There's all kinds of data available for different sites, but really you want to pay your dues and get out there and know your site before you really start investing heavily into a specific technology. And make sure that what you're putting out there is going to work for your site. And if it doesn't work, don't be afraid to look at something else. There's just a huge variation in gear that you can get for growing oysters, or any shellfish for that matter. And so there's a lot of things that you can play around with. Whenever you're growing oysters or any shellfish, it's not so much a biological, technological issue as it is a materials handling problem. You've got to be able to handle a lot of product in a fairly short amount of time to keep on top of the gear. And I'll talk about that more as we get into it. And particularly when you're talking about single oyster production, which is primarily directed for half-shell raw bars, the quality, the grade of that product, the shape, the cup depth, the meat volume are all hugely important in terms of your marketability. And so what you really don't want to do is you do not want to move ungraded animals out, ungraded product out of your farm. Because as you start to develop a name and a brand for your production, you want people to think of your product and your brand as the best. And so you really want to be doing a lot of grading, we'll talk about that a little bit, to make sure that you can consistently get the top shelf price that you want. Simple is beautiful and cheaper is even better. I think that goes without saying. And the last thing you really want to think about, and this is more of a site issue, but it also is a husbandry issue, is that with oysters, they need flow. If you don't maintain flow through your gear, and that flow can be interrupted by site characteristics, but mostly it's interrupted by fouling. And because we're growing these things up in the water column somewhere, fouling is a huge issue on this gear. And with increased fouling, you get increased restriction in flow, and if they just don't get enough food or enough oxygen, that's going to stunt their growth, and then you're going to start running into some real production problems. Some other things to think about, and this somewhat dictates what kind of technology you're working with, is if it's really easy for me to get my oysters out of that area, it may be easy for somebody else as well. We just had a big case up on Cape Cod where last summer a couple of growers lost about $40,000 worth of oysters over the course of about a week. Whoever was doing it hit them 2 or 3 times over the course of a week and basically took bags and gear and everything. They just busted them last week to everybody's pleasure. Obviously, matching gear to your site, permits I'm not going to talk about. Weather, extreme conditions. For us, our extreme conditions are mostly winter, ice, and storms. But we still, down here, I suspect storms are a big issue as well. Some of this gear sits fairly high up off the bottom. And so tipping over is a pretty big deal, because instead of having a large bag surface area that your oysters can spread out on, if your cage, for example, flips over and now you've got everything jammed down on the bottom, then that's going to severely restrict your growth and survival to some extent. Predation and access and ease of handling the gear is all are important considerations. So let's look at some of this technology, and I can show you some examples of what's going on up north, and you can think about how you can adapt it or adopt it for your sites. And the first and easiest and probably the oldest technology that we've got for growing oysters is just directly free planting on the bottom. Now, a lot of this gear and a lot of this technology I'm going to show you are intertidal sites. And the reason I'm showing you intertidal sites is it's a heck of a lot easier to take pictures of it than when it's submerged. And so all of this gear and all of this technology can be used in subtidal sites that I'm going to talk about. But the pictures, it's easier to demonstrate it in air. So ignore the fact that you don't have any intertidal, and all of the stuff I'm showing you is intertidal. So bottom planting. We've been doing this for a long time. Rhode Island in the late 1800s was producing what's equivalent to millions and millions of dollars worth of oysters that were shipped all over the world. And it was just a matter of taking oysters out of seed beds, and usually in a managed oyster fishery, they will culch them on specified seed beds, which have a history of recruiting small oysters onto them. And then after the first year's growth, they'll drag them up and then move them out to the grow-out beds, which may not recruit, may not get babies quite so easily, but certainly the conditions are optimal for those animals to grow. And we still have areas that are using this this 1800s technology. Almost the whole aquaculture industry in Connecticut is based on just free bottom planting from seed beds to grow out beds. And so basically there's some things that we do to try to make this work. For free planting, for free bottom planting, the trick is to get as big an animal out there as you can because they're not protected. So all of those predators that are wandering around looking for a free meal are going to pick up the smaller oysters, and because what we grow are single oysters exclusively, they're much more susceptible to crab predation and whelk predation and conch predation and all of the other things that eat our small oysters. And so we really need to get them up to at least 1.5 inches and better even to 2 inches before they free plant them out on the bottom. And so there's a variety of different technologies they use for nursery culture to get them up to those big sizes, upwellers or floating gear bags or a whole variety, Taylor floats. Generally we're planting at a density of 300 to 600 bushels of seed per acre, and that translates to somewhere between 100 and 200 oysters per square meter, or about a square yard. And that seems to be a reasonable density because, I mean, you may think of 200 oysters per square yard as a lot of oysters, but you've got to remember that using this free planting technology, you have a fairly high mortality rate. And so by the time you're out there harvesting, that bed has probably been thinned down to 25% of what you initially put out there. The other thing that you want to do as you're planting on the bottom is to be very careful about size grading and putting things out on individual plots. Because particularly if you're doing this in a subtidal bed and you're probably going to be dredging up those oysters or raking them up, you want to make sure that the bulk of the oysters that you're bringing up are all market size. So you don't want to have to handle them and then maybe have to replant half of the bed that you pulled up because they're too small. So what we do is we try to size grade very carefully and then plant like-sized animals in discrete patches so that when we come back to harvest, we have a fairly good expectation that everything's going to come up at a market size. In Connecticut, this is one of the Connecticut free planting boats, and basically they just harvest by just a classic old oyster dredge, bring them up on deck, pick through them. A lot of this is done, it's basically spat on shell production because the seed beds, they just culch them directly. And so these oysters are a little bit different from our conventional, or what we think of as our classically farmed oysters where there's a high percentage of singles. With spat on shell and this free planting on the bottom, they're only getting maybe 10 to 20% singles, and the rest of them are clumped oysters, which probably will go primarily into the shuck market. One of the things that they do down there to try to reduce the risk of predation on them is they try to do some various types of predator control. This is a starfish mop, and it's literally what it sounds like. It's just a bunch of mop heads of cotton fabric or some kind of fibrous material, and they just drag these across the bottom. And the starfish, because they have all those prickly exoskeleton or exoderm on them, they get tangled up in these mops, and they bring them ashore, bring them up on the deck, and this is a bucket of heated water, and they'll just drop the whole mop into basically to just cook them alive and get them. Obviously, you don't want to try to cut them up and throw them back overboard. This is a smaller scale oyster dredge. This is a small Cotuit oyster farm over in Massachusetts on Cape Cod. And he free plants in about 10 feet of water, 10 to 15 feet of water, and does most of his harvesting just off this small oyster dredge. He's free planting, for the most part, single oysters. And again, you have much higher predation losses due to single oysters than you do planting out, free planting spat on shell. There are some real advantages. I mean, you may think, well, geez, if I lose 50 or 60 or 70% of my animals, that it's just not going to be worth it for me. But you got to remember that you're putting them out there and then you do nothing to them until you harvest them. And so your labor costs and therefore some of your considerable amount of your operating costs are reduced or eliminated, because after you get them out of the nursery and free planted on the bottom, there's nothing to do till you'll harvest them. So there's a lot less labor, and obviously you're not buying any containment cages or racks or whatever it is, SEPA bags or whatever. So it's really, you got a boat and you got a drag and you got a nursery system, and that's about all you need for doing a free planting system. They really, because it's basically a natural oyster grow out system, it's usually, at least in our case up north, permitting's a little bit less onerous because you're not putting a lot of physical gear out on the water. And the upland neighborhood doesn't seem to have as much of a problem because there's not cages and buoys and boats and all kinds of things going on over there. Obviously, some of the disadvantages involve predation and loss of animals to predation. There are tools for doing predation control. Some of them are a little bit more onerous than others, and you may run into some resistance for that. One of the things that oysters don't like to do, and that is get silted fairly heavily. And so if you're in an area where there's a lot of dynamic sediment movement, or you get a high siltation rate, then that's probably not going to be the best area. Although I have to admit that oysters are maybe a little bit more tolerant to silting than you might think. One of our growers had for years, he was growing things in bottom cages, and used to, at the end of the year, he always had one bucket of runts left over. They never seemed to grow. And so at the end of the year, rather than bother dealing with them, he just basically dumped them overboard, figuring that he would feed the crabs. And then he was working on his site one day and he dropped a wrench overboard, and he decided he was not going to lose that wrench. So he jumped overboard to try to find it with a snorkel and mask. And it was real soft mud on the bottom. And when he got down there, he noticed all of these bills just sticking like a quarter of an inch out of the mud. And so he started digging around there, and lo and behold, all those runts he'd been dropping over there for years turned out to be beautiful oysters, absolutely beautiful oysters, for a variety of reasons that I'll get to in a while. And so he immediately realized that first, they're not anywhere near as susceptible to soft mud mortality as what we originally thought. And secondly, it was a hell of a lot easier to grow his oysters by dumping them over the side than it was putting them in cages. And so he switched his whole operation over to bottom free planting, and it worked very well for him. And then if you're planting spat on shell, then anytime you put a shell down on the bottom, the stuff on the bottom is going to die. So you're going to lose half of your set, or assuming you're getting even distribution on the top and bottom of your shell. You're going to lose a large percentage of it as you lay stuff on the bottom. Some people just directly, they bag them in oyster bags, and I'll talk about these in a second, and then they just lay the bags directly on the bottom. And sometimes they build these little wire staples that look a lot like croquet wickets, and they'll just put a staple through a corner of the bag and just step on it and push it down into the mud and to hold the bag in place, and they'll just lay their bags out on the mud. If you're in a fairly hard bottom with not much material sediment being moved around by currents or wind, then this is a reasonable way of trying to grow oysters. However, if they do start getting silted up and you're getting a lot of sediment buildup in there, then you're really going to get into trouble. Most of our growers up north will just throw bags on the bottom, but they use it for really short-term holding. It's usually as they're doing grading on site, and so they will keep their markets and just load them up into bags in a 200 count or a 300 count, and then they'll just throw the bags on the bottom, and they sort of have them in reserve, so as their orders come in, instead of having to go out and grade and count every single oyster, they'll have them already pre-packaged so they can just start pulling these bags up. But they don't want to go to a lot of effort of putting them into a cage or gear or something, because they're just going to be pulling them out the next few days. So they'll do just a direct bag on the bottom. Let's talk a little bit about oyster bags. I'm not sure if you've had a lot of experience working with these. They're a semi-rigid bag made out of high-density polyethylene. They come in a couple of different configurations. This is a diamond mesh, and that's a square mesh. bag. Square mesh bags are usually, the material is a little bit lighter because they're actually originally were made so that they could be bent into these what we call up north suitcase shapes. And basically you can bend this square mesh on the mesh, and then if you make a couple of cuts on the ends, you can fold them over just like a cardboard box type of package, hog ring at least one end together, and now you've got something that has a sort of a semi-rigid volume to it. Some people think that oysters, if they have a bag compressing down on them, they don't feed as well. I'm not convinced that that's the case, but that is some of the rationale why people are using these square mesh bags that are folded into suitcases. For the most part, I use, and I grow a couple of 100,000 oysters a year through my university because it gives me something to keep the students busy so I don't have to teach them. So we use all diamond mesh bags, and they just have a single seam or folded seam on each edge. They come in a variety of different configurations. You can have bags that are open at both ends, in which case you're going to have to do something to seal them. You can also buy bags that are sealed at one end and only open at the other. The other thing is they come in a variety of mesh sizes. And so everywhere from a really small mesh, 1/16 of an inch, which some people use for nurseries, but they're a pain in the neck because they silt up and they plug up almost instantaneously when they hit the water, all the way up to what's effectively a 1-inch mesh bag. And so obviously you want to continue as your oysters grow to put them in a mesh bag size that is the largest mesh that will effectively hold them in place. Because the smaller the mesh, the quicker it's going to plug up to fouling, and the quicker you're going to lose flow through your bag. And that means you're just going to have to handle it and clean it that much more frequently. And so the real challenge is to keep these things growing fast and so that you can get them up into a larger size bag as quickly as you can, and that sort of cuts down on your workload. And then you can buy them in all kinds, as I said, different configurations with sealed ends and reinforced sides and diamond mesh or square mesh. And then there's a variety of ways of closing these bags. Because I use diamond mesh bags, this is one that's sealed on the end. And my preferred method is using a PVC pipe clamp. And it's just Schedule 20, 3/4 inch PVC. And you just rip a kerf down one side of it with a table saw, nip off one edge so that you can use it to feed it on, and you can just slide this right across the end of the bag and seal it up. If it makes you nervous that just having that single clamp, then you can take a nylon zip tie and you can put a zip tie through it and just clamp it down, and it holds pretty well. Another strategy that people use a lot are these, what I call diaper pins. They're just stainless steel bent pins. You can buy them from most any aquaculture supply place. And you can either fold the ends over and clip them with these diaper pins, or some people will use some kind of bungee apparatus, and then you can buy these sort of gooseneck clips that then you can insert back into the mesh and hold some tension on that bungee to keep that folded end over. And what you have to do when you're folding these ends is you usually have to cut some slots on those so that they can fold back in on themselves so that you get a complete seal on the end of the bag. Most of our growers are using some kind of off-bottom techniques. Oysters grow a lot better if they are up off the bottom. They get a little bit better quality food, and then they get much better flow. And so if you were to do an experiment on your site and put oysters on bottom and then elevate it off the bottom, you'll find that you'll probably get a 15 or 20% faster growth rate from animals that are up off the bottom. And so most of our technology takes advantage of that growth advantage and raises stuff off the bottom. This is not a way that I would recommend anyone doing it, and I don't even know why I keep this slide in here, because I have visions of some little kids running around out on the flats. This is an area that's right off a recreational beach, at mid-tide, and then they run into one of these rusty old pieces of rebar and rip a hole in their leg or something, and it's not a pretty scene. But there are some technologies that do work well, and this is something as simple as just open trays on the bottom. They're made out of, we make them out of 1-inch, what we call lobster trap wire, which is 1-inch mesh welded wire with rubber coating on it. It comes in 4-foot wide sections, so you just cut it so you can bend up 6 inches on each side, and you can build these trays. And they come in a variety of configurations. Usually what people will do is they then bend a separate piece of wire and hog ring it on the bottom as standoffs, so now you're elevating everything up off the bottom. And obviously it takes a relatively hard bottom in order for these to be effective to hold the animals in the cage system or the tray system up off the bottom. So this is one that's down by me in Rhode Island. He's got an absolutely wonderful site and grows oysters. As you can see, he's got these trays just absolutely jam-packed full of oysters. And for some reason it works for him on this site. I would never recommend that you crowd them as much as he does. But as I say, as you get to know your site, you can figure out what its capabilities are, and then you work with what you got. And in his case, he's got a pretty good deal. Some other tray systems that are fairly popular are these. This is an Australian aqua tray, which is a molded plastic tray that you can buy, and it comes in a couple of different mesh configurations. It has these internal partitions that prevent the oysters from being washed around. If you put them into some kind of wave zone, if you didn't have these, then all of the oysters would end up being pushed over to one side and being really overcrowded, and 75% of your tray would not be used for holding oysters. So they build these partitions in to hold the animals so they keep relatively evenly distributed across the entire surface area of the bay, of the tray. They come with a plastic snap-on cap, or if you stack them one on top of the other, I'll show you some stacked ones in a minute. The one on the top forms a sealed cover for the one on the bottom. And so you can literally stack these up. This is a hanging system, which is why they've got some space in between them. So you can elevate these off the bottom in some kind of tabletop system. This is in Australia. This is a double backbone long line that is very similar to the Australian long line system, except now they're, instead of hanging those single baskets on each long line, they're double hanging these aqua trays. I don't like these very much, but I don't like them because in the wintertime they get really brittle and break for us. Down here they may be a very viable way of growing oysters.
Are they polyethylene?
I believe they are, but I'm not exactly sure what the material is. I don't know. Sorry. This is one group that grows them out by me on Cape Cod and Dennis, and as you can see, they're pretty well committed to oyster grows. And if you look carefully, these are actually three trays that are stacked together, and they're held in place by just each of the corners has an opening that allows for it to slide over I think it's either 3/4 or 1-inch PVC pipe, and so you can just jet your pipe in the water, and we just use a pumped stream, connect onto the end of the pipe, force water down here, it liquefies the soil, and you can just run your pipe down to 3 or 4 feet into the sediment without any kind of digging or real huge exertion. And then they put a stopper down here to keep that tray elevated off the bottom. And they've been having really good luck with these out in this one fairly large sand flat. This is the area where those guys were stealing the oysters this past summer, right on this very farm. Probably the system that is most popular down our way, this is what I use almost exclusively, and a lot of growers do, is what we call a rack and bag system. And it's nothing more than just some kind of fabricated tabletop that you can then place on the flats that has an elevation that you can now put your bags on. And as you can see, these are made out of rebar, and they come in all kinds of shapes and sizes. Just to give you, this is one schematic of one design, but it's 10 feet long, and it's a little over, it's basically a bag length across so that you can actually then lay a sequence of bags down on it. And then you make these sort of splayed legs on them, and oftentimes they will bend the foot out. And they're all welded up into this configuration, and they hold up fairly well.
I have a question over there.
Yeah,
I had a question.
Sure.
On this and
the trays.
Polypropylene
Uh-huh.
racks. Okay, this is in an intertidal area.
Yes.
That'll only work because otherwise it would be, there would be too much biofouling? Or
No, you can, all of these technologies will work just as well subtidally. Like I use rack and bag subtidally. My site, I've only got about a 2-foot tide excursion at the university because I'm way up at the head of the bay. And so everything that I'm doing is about, I maybe have a foot of water over the top of my racks at low tide. And at high tide, I have 2 or 3 feet. In some places I've even got 5 and 6 feet.
So you don't flip them up and dry them out?
No. What we do is we bring them ashore and we switch out gear. So we'll talk about that in a minute. But basically you have an extra set of gear or portion of gear at shore that you can let the bags dry out. And then you can just dump one bag over from a dirty bag to a clean bag, let the dirty bag dry for a couple of days. If you want, you can hit it with a pressure washer, or once the stuff dries, you can basically just take a stiff brush and take everything off. So all of this gear, as I said earlier, is perfectly amenable to doing subtidally as well. You just have to sort of change your management strategy to deal with fouling. Some of the people, if you're in a softer substrate, this is a slide I stole off Andre's website, and they call them slippers, which I thought was kind of cute. But they basically just pin them down onto what I used to refer to them as snowshoes on the rack, so that there's a lot more surface area and they won't sink down as much in the mud as you would if it was just this bent foot. Now, for us in the wintertime, having just that bent foot is a good thing, because when the ice comes in, it literally just pushes that table down to the bottom, right down to the sediment surface, and then the ice just sits on top of it. So the oysters don't mind being pinned under ice. What we don't want is the ice to pick that gear up and then transport it off. And then you just come out in the spring, and by this time everything's basically flat on the surface, and you can just put a lever underneath it and you can pop those racks back up to the surface again. And now you've got your elevated system back and going. Probably not a big concern for you down here. But certainly putting these slippers or these footprints on these, it would be an advantage in a softer sediment area. So this is a rack and bag system out in Wellfleet, and as you can see, this is a fairly fine mesh bag, so they're just putting their summer seed out on these. And normally you can't really see it very well. I think you can see it better on the next slide. But they're just pinned down we just hook bungee loops on here. And so you can just pull the bungee off, pull your bag off, put a new bag on, and flip the bungee back up. I think you can, to pin them down. The other thing that you can do is we oftentimes will double them up just to get twice as much gear and oysters in a certain footprint of rack. And so doubling is not bad, putting them one directly on top of the other, but I'm not sure I would go any higher than that without separating them like they do in this one. This is a system that's over in Barnstable. And these are racks that actually can be disassembled. Transporting those big racks is kind of a pain in the neck sometimes. If you build them right, you can stack them so that they sort of compress down, but it's still a 10-foot long by 3-foot wide structure that you have to be carrying around. In this case, what they've done is they just made these end units and then drilled holes in it so they could just run the length of rebar through there, so they could actually just pop this end off. And then they have a bundle of rebar and a stack of ends, and that seems to work very well. Here you can see the bungee a little bit better. So it just pins over both ends of the bag and holds them in place. And it's not, we very rarely do you lose a bag off these systems using that. That right there is maybe 3 feet high, 3.5 feet high. And that's the beauty of at least the earlier rack systems, is that you can make the legs just about any length you want, if you have some height restrictions. In Massachusetts, the Army Corps, through our programmatic general permit, dictates that we cannot have anything over 18 inches off the surface of the sediment. Sandy's starting to agitate. What?
Is that pipe on the corners?
Pipe on the corner. This?
Yeah.
No, I think it was either steel or aluminum rod that they welded onto these plates. I think it was aluminum, if I remember correctly. One of the things that you have to be aware of, and this is something that's always a huge surprise for people that are just starting out in the oyster business, is what we call the Jiffy Pop syndrome. And that is, you start in late June with 4 millimeter seed, and by 6 months later, you now have something that is 10 to 20 times the volume. So if you're using bag culture of oysters, you start off with a bunch of oysters, and you can get a whole mess of half-inch oysters in a single bag, because we usually stock them somewhere. We measure them by biomass, by volume, rather than by counting. And so we'll put 1.5 to 2 gallons of oysters in a bag, and that translates to up to 20,000 oysters when they're small. But our final market size density is somewhere between 150 and 250 oysters per bag. And so if you start out with 50,000 oysters, you can fit all of your oysters in 2 to 3 bags in June, but come October, you're going to need 300 bags, or come, depending on when they're starting to get bigger, you're going to need a very large number of bags. And what frequently happens with us is that I start getting phone calls about the middle of August, early to middle of August, with growers that are absolutely in panic because they didn't have enough bags on hand in the right mesh sizes. And by that time, all of the suppliers have sold out of their oyster bags. And so now they're having to double and triple up their biomass in a bag. And that will just absolutely trash your growth rates. If you overcrowd these bags, these guys will make you pay for it by just not growing. And so you need to anticipate how that volume is going to change over the course of your growing season, and how that translates into the number of bags that you need of a specific mesh size. And so obviously a lot of this doesn't come until you've had some experience doing it, and so you can sort of see it for yourself. But nevertheless, it's something you really have to think about and have to be aware of, that the number of bags grows exponentially as these animals get bigger. Australian longline system you guys have seen. I'm not going to talk about that. But the only thing I will mention is that many growers, again, taking advantage of that three-dimensional space as they elevate those bags on those racks up off the bottom, will try to take advantage of that space underneath it. So they'll hang SEPA bags or some other type of tray or something underneath there. So that just allows them to get more oysters within a square foot of footprint of the culture system. So rack and bags, for the most part, they're big enough to, I'm not sure I would go along with that. I stole these off Skid as well. No, actually, no, I think I wrote these. But after their experience last summer, which was a rack and bag in those Aquaculture systems, they ended up just taking everything. They pulled the bags off and just took off with the gear and the oysters. So I'm not sure that that's probably a good advantage. But what you're doing is you're elevating the oysters up to get good flow. They're easy to maintain in the fact that you can pull those bags off fairly readily. They're small enough so that you can handle a bag by yourself. You don't need 3 men and a boy to pick up a rack of oysters. They're not very expensive. A single bag costs about $5 if you buy them in volume. And those racks, last I knew, the local welder was charging, I think it was like $60 or $70 a rack, but it depends a lot on the price of rebar and steel, which has been going up ridiculously. And one of the things that it does do is if you have it in an area that does have some kind of wave action or water movement, it bounces those oysters around a little bit in those bags, and that sort of knocks off some of that new bill and forces them to grow a deeper cup. And so oftentimes you'll get a much better looking product in these oyster bags that are up where they're getting a little bit of action. And I'll talk a little bit more about that in a minute. In some respects, it's certainly a much larger capital cost than just free planting on the bottom. No question. They can tip over to some degree, although I've never really seen it happen to any large degree, except when we have some kind of ice event. They are heavy to get those racks out there and move them around. So and some people will put these in really deep water by hooking a bridle up on them and then lifting them and lowering them so they will configure the whole rack. They'll put 5 to 10 bags of oysters on a rack and it has a bridle on it, and then they'll just lift the whole rack up and drop it down, and then when they go to maintain it, they'll come back and they'll pick up that bridle and pull that rack back up on their barge and then work it, the whole thing as a unit. So if that's the case, if you're working in deep water with a rack system, then you're probably going to need some way to get it up. They are somewhat storm-proof, but this is a system that we're starting to play around with it, which I don't have any original ideas. I just steal stuff from other people. And so this was a technology. First I ran into it. I don't know how I found this old patent, which not that old. It was 1987. I was sitting on the web one day and I thought, well, isn't that interesting? You can put a float and actually put a bag containment system that rotates. And then shortly thereafter, I was out in Seattle at another one of our National Shellfish Association meeting, and they were talking about what they call flip bags. And I thought, what the heck is that? And so I went to the talk, and we'll get back to that. And basically what they're doing is they're setting out these long line systems, and they're putting their bags, they're pinning them on one side, but then they put a float on the other side. So as the tide comes in and out, it lifts and drops those bags. So literally you're tumbling them with every tidal cycle. And the quality of the oyster that you get out of this thing is unbelievable. Well, I'll get to that in a minute. That's all right. I've been growing them using these flip bags for the last 2 years, and I served a bunch of them to some folks last November. And Skid, the director of the East Coast Shellfish Growers Association, is still raving about the quality of the oysters that were coming out of these flip bags. And what happens is by knocking that bill off, the animal stays really small. So rarely do they get up to even 3 inches, but they develop a cup that's almost as deep as they are long. And so when you open those things up, you think you've got this little tiny oyster in there, and it's just jam-packed with meat. So on the West Coast, they're marketing these with a special name. They call them Kushi oysters, or other places call them, I think there's another Miyagi or something like that. And they're getting another 25 to 50 cents an oyster for them.
It just floats
So,
constantly with the tide?
yeah, so as the tide comes in, this end floats, and so it just rotates up. And so the oysters tumble down, and then when the tide goes out, it slowly goes down and the oysters tumble the other way. So you're constantly knocking off that new shell growth, and that forces deep cups, like unbelievably deep cups. This is just another configuration of it here. They just use those plastic swim noodles, and they just zip tied them on to the bottom. And then I use those, I put a wooden dowel inside of the bag, and then those diaper pins hooked around it. If you hook it just to the mesh of the bag, it can't stand the strain, it'll rip out. But if you put a dowel in there so that you distribute the weight over the whole mesh size, then it works pretty well. And so this is the original configuration. If this is sort of mid-tide, so this is mean low water, this is mean high water. If you're in an intertidal zone and you only need a couple of foot of tide to make these work, then they will flip with the tide. If you want to put them in deep water, we came up with this design, which we haven't tested yet, but we're setting up this summer, where we're going to take 5 bags and have a 20-foot or 10-foot piece of PVC pipe, and we're going to zip tie the bags onto that piece of pipe, and then we're going to put a couple of big floats up to the surface tied to that. So as the tide comes in, it lifts the floats, and that's going to flip that whole rack up so that we can flip them back and forth, even in deeper water systems. I think it'll work, but we'll see. And obviously, you have to anchor off. You have to anchor off. We're going to put in some small helical anchors to anchor off our. So basically, it's a dynamic, high tension long line system here. And on shore, we're gonna rig up some. I think we're going to try to use bamboo posts and try to rig them out on some flats this summer. We just got some funding to set up a research farm network. So we got 5 farms in all of the 5 northeastern states that we're going to be setting these demonstration projects up, and then have on-farm demonstrations with all the local growers. The other way that you can elevate stuff off the bottom is a full-blown cage system, and these are bottom cages that are routinely used. They come, again, in a whole bunch of different configurations. They're basically built so that you can fit 1 oyster bag or sometimes 2 oyster bags in each one of the shelves on these cages. And you can get something as simple as a 1-bag rack, which is basically the same as a tray. I use 5x2s. A lot of people use 3x2s or 3x3s. And so you can get up 9, maybe even up to 18 oyster bags in one of those bottom cages. And we've got people that are using these in 15, 20, 30 feet of water fairly successfully. Obviously, you're not going to be taking a hand and hauling these things up to the surface by hand. You're going to need a boat with some kind of pot hauler or some kind of hydraulic lifting device that will get these things off the bottom, which is a bad thing and a good thing. It's a bad thing because it's extra work for you. It's a good thing because nobody else, some recreational day boater, isn't going to come and pull up one of your cages and grab a bunch of oysters for their lunch because they're just not going to be able to get them up to the surface. So this is a 5x2 bottom cage. They're just made out of, again, that plastic coated wire. In this case, it's a 3-inch mesh. Because you're putting them in bags inside, all you need that outside wire to do is provide structural rigidity. And so we have here 5 shelves with a divider down the middle. And as you can see, in this case I had bay scallops in them, but you could put 10 bags. And when I really get brave, I'll actually take zip ties and I'll zip tie a couple more bags on the top. If I'm running out of space or cages. These are fairly expensive. They cost around $100 to $150 a cage, depending on the configuration that you get. But they have a fairly long life expectancy, as long as you don't leave them under your float. So when the tide goes out, the float comes down and crushes them. I speak from experience. This is another cage configuration. This is a picture I stole off the web, and it's some folks down in Virginia, and I'm not exactly sure. I guess those are individual cages. They're fairly, initially I thought that somehow they'd made a big cage and then put gaps in them, but now that I look at it and think about it a little bit more, those are just, they look like 2x2 cages. But as you can see, he's got a small little crane and davit for, huh? You think they're too big and 2x2? Okay, I'll take your word for it. I don't know. This is another thing I stole off the web from France, and this is about the largest amount of overkill I've ever seen in building cages. You're not going to be lifting this thing up very easily, I can tell you. It'll last you for 100 years probably, but it would be a killer to try to handle this thing. And obviously, this is some we built for doing some sea scallop stuff out in really deep water. We were running these in about 120 feet of water. But the reason I threw this in here is because a lot of guys will rig them up on trawl lines so that you don't have a lot of surface buoys. And oftentimes they'll just get rid of the buoys altogether and they'll just grapple them up. And that really cuts down on interference from outside people coming along and trying to pull them up. Obviously you need to be able to handle these things, and people have developed all kinds of configurations on barges and boats and ways to get these things up to the surface. This is one where they've got cages on bags and cages here, and they actually have their tumbler right on board as well, and so they can bring them up and process them, grade them, and tumble them, and then repackage them and drop them back over. This is one that a friend of mine was in the process of building out in Wellfleet, and he was sort of halfway through constructing it. But it was neat because there was a company in Canada that was making these high-density polyethylene flotation logs, and they were relatively inexpensive, and you can get them like 15 and 20 and 30 feet long. And then obviously you have to put some kind of lifting rig on there. This is one where they built a small A-frame that could flip off to the end to pick up the cage, and then a hydraulic system to rotate the whole apparatus so that the cage could swing on deck so that you can get access to them. Another friend of mine brings one up, and he doesn't even bring it on deck. He basically brings it up to the side, and then he rolls it so that the bags are now standing up, straight up and down, and then he can just reach over and lift the bags up. With that 3-inch wire mesh, it doesn't foul to any great degree. It's the plastic bag mesh is foul, but the big wire mesh doesn't foul to any great degree. So you can basically leave those cages in all season without a huge amount of maintenance. If it's a 1-inch wire mesh, which some people do make cages out of that, then that's a different story. Then you're going to have to be handling those a lot more. So with off-bottom culture, I didn't really talk about it, but once you start getting those things up off the bottom and containing them in bags, now your predation risk has been dropped considerably. About the only thing that can get into those bags and cause you trouble are oyster drills, which are small and a pain in the neck to deal with. But it allows you to take advantage of a lot more of the volume of the space on your permitted site, because you now can stack your bags up in 3 dimensions instead of just flat across the surface like you would have if you were just doing straight bottom pinneting. It's fairly expensive to buy these things. It requires a lot more labor, both for setup and for handling fouling. And there are some concerns when you start looking at other users. I had a bunch of these growing bay scallops out in Nantucket Harbor a number of years ago, and I heard I was going to work one day, and I ran into this guy who just out of the blue started telling me about a water skier that ran into a cage when they were water skiing out in Nantucket Harbor. And it turns out somebody had picked up one of my bay scallop cages and brought it in real shallow. And so when the water skier, literally they came through and hooked a ski on the cage and just took them out. I never heard anything official about that. So if you know who it is, just don't tell them it was me. We have a few risks that we have to deal with any kind of winter sessions. This is not generally what we have to deal with down around Rhode Island and Massachusetts, but the farther down east you go, the more you're going to have to deal with ice issues and how do you harvest and tend your oysters in the wintertime. And so we spend a lot of time thinking about how to overwinter oysters, because if you're in an intertidal zone, and I've seen basically icebergs coming through that intertidal zone that are 6 feet thick and 10 feet across, and if they run into an oyster cage, it's not going to slow them down very much. But the real problem with our ice is that when the tide goes out, you get all this slush that is now exposed to the air, and it freezes solid, and it picks up your bag at the same time, and then the tide comes back in again, and it lifts your bag and the rack and everything, and off it goes as the drift ice moves away. So one of the things our guys do, and this is kind of interesting, but has no bearing whatsoever on what you guys do, is they overwinter their oysters in what we call pits, oyster pits. And so we can pull our oysters out. Generally they do it when the ice risk starts, which is sometime mid to late December. And they have these underground storage areas, which is nothing more than a root cellar that is insulated on the top. So it's generally being right around 40 degrees in the wintertime, 35 to 40 degrees, just above freezing. And so they'll just take their bags of oysters and they'll just stack them in those root cellars, and they'll leave them there for 2 to 3 months. So they'll put them in December, when the last risk of ice, which is generally sometime late February, so a couple of months, they'll keep them in these oyster pits.
You're talking about on land?
Yeah.
Not in the water?
Not in the water,
Yeah.
just in the air.
3 months?
2 months. And you get some mortality. You may get 5% mortality, but
Maybe we need something like that in the summer when it gets so hot.
well, it's got to. Okay, here are some of the things you need to do.
Outside the house, underwater.
It needs to be below 40 degrees, but not freezing. And you have to go in there at least on a weekly basis and spray everything down with water. Because what happens is an oyster will air gape to get oxygen, which means they'll open up and they actually can get oxygen transfer across their gills. But if those gills dry at all, it's toast. And so you have to make sure that the humidity in that system is 100% humidity all the time. No, I've got this.
What I meant was underwater in a
Well,
space where it's cooler because it gets real hot.
you have to make sure you get, when an oyster's underwater, then it wants to breathe. So you're going to have to be very careful about your oxygen levels if you do something like that. But oxygen in the air is 20%. Oxygen in water is 0.002%. So it's, they get plenty of oxygen, but if they damage their gills, then they're toast. So you just have to make sure your humidity stays high, and you can hold them there for a couple of months.
And the ocean would be 100%, right?
Oh yeah, yeah. So let's talk a little bit about suspended culture. I've still got 15 minutes or so, 20 minutes. Okay. Oh, ramp it up. All right, suspension culture. If anybody's thinking of working in deep water systems, these surface long lines seem to work pretty well. And it's basically a clothesline that you run across the surface that's supported by buoys. Okay. And some people use a bunch of different technologies. These are pearl nets. These are lantern nets. I'm not going to spend any time talking about these because I absolutely hate them. They're a complete waste of effort because they involve so much handling of the animal, and it takes so much time to get animals. You see this little wire, this little yellow cord here? The only way you can get in and out of these things is to stitch and unstitch a seam along that edge, and then you dump your oysters out. And so you have to literally unstitch it to dump everything out and then stitch it back up again. It takes you a half hour to do one lantern net. It's just a complete waste of time. But I like to at least make people aware that that's something you should definitely stay away from as much as you can. What has really become popular are these hanging tray systems, and they are working very well. And they come in a bunch of different configurations. I'll show you a few more pictures of different hanging tray systems. But basically, you just rig up a rope bridle. They usually have some kind of connector on the edges so you can run your rope through it, so that basically they're just held together by weight and gravity. Oysters are stacked inside. You have multiple layers with enough headspace so that water can flow through. This is a suspended culture farm that we've got just down the bay from me in Rhode Island. And as you can see, they've got a fairly, under each one of these buoys, or not every single one, but on a populated long line, they've got a stack of 6 to 10 cages hanging underneath that buoy. As you can see, they're fairly good size, and they grow oysters like crazy. This is about 30 feet of water. So these things are probably hanging mid-water with about 10 feet of water under them and about 10 feet of water over the top of them, which cuts down on the fouling to some extent, at least the plant fouling growth. Their big problem here is mussel set on their system, and they're constantly having to clean mussels off. But it's a fairly nice system. Unfortunately, it's very expensive because you need.
Where is that?
That's Bill Silks' place. That's down right off Melville. You need a boat that's specifically rigged up for doing this with star wheels so that you can handle this backbone that the trays are hanging off from, and you need all of these buoys, and you need anchors and moorings, and it's a very expensive proposition, at least for the upfront capital costs. Some people hang these things off rafts. Another option. Again, this is just sort of a classic aquaculture raft. So everything just hangs off these stringers that are suspended off flotation systems. This is just another picture I stole off the web. I've never actually seen one of these in real life. This is one tray system, some people call these Mexican trays. This is sort of an old school way of growing oysters. And they have really, as you can see, the void spaces of plastic here, they really restrict the flow. Not a very good way to grow oysters. You can do aqua trays in these suspended systems. Here's an aqua tray suspension system. This is one that Rick found. Remember that, Rick? This was an Italian tray system that we have never. Do you have that?
I have one.
Where'd you get it?
From the people. I stole it at a trade show. They gave it. I didn't steal it. They gave it.
Really? So I just thought it was pretty. It's nice and blue.
It hangs up nice in my
Yeah, look,
plant-based nursery.
it's very nice and blue. Yeah.
I don't know when to ask this question, but I'm interested in the color of the cages and also polypropylene versus polyethylene.
I can only very rudimentarily answer that.
Those are polypropylene.
These are polypropylene. I don't think the actual plastic material makes much difference on fouling once the plasticizers, once they've been leached out, which happens fairly rapidly. Color is another question. I've had a number of people that have speculated, and it's all anecdotal, and we don't have any hard data, that certain colors seem to attract fouling organisms more readily than other colors.
Black
Black is supposed to be the one that attracts the most.
and blue is the best.
I thought it was red or orange, but like I say, it's all anecdotal. So if you talk to 5 different growers that have played around with it, you get 5 different answers.
This is by the FIT folks that make a living out of testing anti-fouling paper.
Really? Oh,
For
okay.
all these companies.
Yeah.
I know that if you want, like, flies to be attracted and stay off of you, you can paint a ball blue and they will go to the blue and stick to it. Now, that is weird, but an archaeologist friend of mine does that. It's a blue balloon, put sticky stuff on it, and they go to it.
I do that in the house for deer flies, it works great.
Really?
No problem with flies, exactly.
It attracts
Now,
everyone.
the blue seems to be the magic for attracting. Is that right for deer flies?
Absolutely.
Absolutely.
Okay.
Your lawnmower, you won't ever get bit.
Exactly.
Well, I was going to go through all that fouling and stuff. I can.
Yeah, let's do that. Let's
We
do
want-
that.
okay.
No, no, keep
All right.
Keep going.
Keep going? All right.
We'll take a break in a minute.
Just a couple of odd ways that people grow oysters, which I thought was kind of interesting. Here they glue individual oysters on stakes and stick them out on the bottom. Here they take 3-parted polypropylene rope and they unlay the strands and stick the oyster through it. Interesting. This is the one that actually has been tested fairly heavily. You take a piece of line and you put an oyster down, and then you put a glob of quickset cement on the oyster that surrounds the line, and then you put another oyster on top of it and let the cement set. And according to Andre Malay was the one that showed me that. And he grows them in vertical hanging systems, and he also grows them on longitudinal systems. The labor involved in growing, I don't see how it works, but according to him, he gets, yeah, well, we get that too, but that's still a lot of labor. Some of the stuff that he was talking about, they get really good shape, he said, and I don't know how he gets an acceptable cost of production, but they will fall over, and they haven't totally worked out the technology. I just thought it was kind of funky, so. They grow these things like suspended off rafts and stuff. And this is an economic analysis I did of a bunch of different technologies. I suspect it was probably contracted by the Australian longline system because they came out the best with the least labor, and I'm not convinced. But here you can see, and maybe Leslie can make this PowerPoint available to folks. So look at that a little bit more carefully. I'm not going to go into all the details of the cost per unit oyster produced. So let's talk a little bit about maintaining all of these systems. They all are subject to pretty much the same kind of husbandry requirements, and almost all of that is focused around fouling and fouling on your gear and how to maintain your oyster bags so that you're going to get flow through them, which, as I mentioned earlier, is critical for growing oysters. These are some of the critters we have to deal with, and some of them may look familiar to you. This is Styla, which is a solitary tunicate. It grows just as one single animal. They filter. You can see the inflow and outflow siphons. So not only do they occupy space and block up your gear, but they also filter the same food out that your oysters are eating. And so we don't like them very much. And there's not much that eats them. They're a non-native species that was introduced. This is Mogula. This is also called sea grapes. And again, inflow and outflow. Here you can see the gut here is all full of food that they've been filtering that your oysters are not going to get. We have a huge problem with these in our upwellers because they settle in. They have just a little biology. They're actually called hemichordates because their larval stage has a backbone. And they look like little tadpoles. And then when they settle down, they lose that backbone and they turn into an invertebrate. So they're sort of that transition animal between invertebrates and vertebrates, which makes them scientifically interesting, but I still like to kill them when I get them on my site. This is a related organism, but instead of having a solitary single animal like Styla or Mogula, these things each one of these is an individual animal, still a tunicate, but they grow in these gelatinous sheets. And I'm sure you probably have seen something similar to that around here. And they will overgrow a cage or a bag in a heartbeat. This is didymnum, which Leslie says you do in fact have here. And here you can see it's overgrowing a mussel rope. And here is one of those hanging oyster cages. As you can well imagine, there's not a heck of a lot of flow that's going to go through those meshes with that crap on it. And so this is something that you really have to pay attention to and make sure that you're pulling your stuff out of gear, out of the water, and then dealing with it somehow. This is another critter that we have problems with up our way. It's boring sponge. I suspect you have a similar species down here. And it's a sponge that actually excretes an acid and dissolves these little tunnels in the shell. And then they live in it. So you see these little blobs of sponge sticking out of the oyster shell. It doesn't really hurt, unless it's really extreme, it doesn't really hurt the oyster. What it does hurt is the poor sucker that has to shuck that oyster. And so he jams his knife into the hinge or in the bill and it blasts right through and then through their hand. And so in terms of marketability, if you've got a lot of boring sponge on it, then they're just not going to, it's really low quality product and it's a problem. One of the things that people have learned how to deal with this is those bottom planting folks. If you plant your oysters in a muddy bottom, and then for whatever reason that boring sponge does not penetrate the shell because that shell is now down below the mud line. And so it has it's proven to be a fairly effective way of controlling boring sponge if you're at a site where you can do direct bottom plantings and then the animals to get appropriately covered with mud but still survive. So it's sort of a specialized location. But nevertheless, it does work. There are some other ways you can deal with it I'll talk about in a minute. Another thing that we have to deal with is overset. Overset are all of those baby oysters that come in and set on your adult oyster. And so up our way, when we only have a few sites where that's a real problem, but literally the growers have to go in and scrape every single oyster as they put it to market to get all of those baby oysters. We have a lot of mussel overset up our way, and that's another whole problem. But there are some ways when you can take advantage of that overset, and that is in generating oysters for your farm. So you can actually set out structures that encourage the settlement of young oysters and then use those young oysters to populate your farm. And this is one of the technologies that we use. They're called Chinese hats. And as you can see, it's nothing but, it's just a stake and you put a rebar in the ground and then you drop this stack of hats on top of it. And they just sit there through the spawning cycle of the oyster. What you do with these hats, they're actually a very flimsy plastic material. And then you dip them in a slurry of cement with a high concentration of lime in it. And lime is what baby oysters orient to when they're looking for a place to set. So you trick them into thinking that that's oyster shell that they're setting on. And so you end up with an oyster with a Chinese hat that could potentially look like that. Now the beauty of these things is you put them through the early nursery system by just leaving those hats out in the substrate, or you can hang them off a float or something like that. And then when it comes time to populate your oyster bags for your grow out, you bring it in, you can disassemble those hats into single layers, and then because they're really flimsy, you just give it a twist or you whack it with a stick, and all of those oysters drop off basically as single oysters. And so now, with just a little bit of cement stuck to the point where they've actually attached themselves to the hat. And so now you can, and if you get doubles and triples, you just break them up. And lo and behold, you now have a whole bunch of single oysters to put in your oyster bags. So this is a fairly, in a couple of areas like Wellfleet and Marion in Massachusetts, where we have a lot of overset problems, they actually, some of our growers use these hats, not as their primary seed supply, because oyster spat settlement is highly variable. And so if you're trying to run a business where you need to produce 500,000 oysters a year, you better buy those 500,000 oysters from a hatchery. And then if you get extra ones, that's just extra money in the bank. But if you have a year where you're relying on 500,000 oysters and you only get 100,000 off your hats, then you're in trouble. There's some other technology that people use. These are called French tubes, and you can dip these in cement, or they may actually make them with this real surface texture on them that they claim works well for setting oysters. And it's basically the same idea. You just give the tube a twist and the oysters drop off. And then these are French tiles. You can buy plastic versions of these that you dip in cement, and then they stack them out on the flats. And again, this is actually how the French collect most of their oyster spat, or a lot of their oyster spat for their grow out systems. Or you can just string up different types of shell. It's called en brochette, but you just put a spacer and then a shell, and you can put them out in these little stacks. And you can, if it's used something that's fairly flimsy, like in this case, these are scallop shells, and then you can just break the shell up when it comes time to form your singles. So let's talk a little bit about fouling control, and then I think I'll probably stop there. How are you going to deal with all of that fouling? Obviously, you can physically remove the stuff. Brushing, this is an array of weapons a friend of mine uses, mostly for his clam nets, because we grow clams under big nets, not in the bags like you guys do. Or power wash, that's Tom from an old picture. Power washing is some of his gear. You can air dry. You've heard about oyster grows and flipping them up. If you're intertidal, then they automatically get air dried every time the tide goes out, which cuts down on the fouling, but it doesn't eliminate it. There are some anti-fouling materials. This is one example of a relatively non-toxic paint that will discourage fouling organisms from setting on it. And some of my growers, it's not approved for use on aquaculture gear, but some of my growers have been playing around with it. They make a very thin version of it. They thin it way down. Actually, this company is now trying to make a water-soluble version of it. And then they dip some of their meshes in it, and then they claim it works really well, especially on their upwellers, on the bottom sieves on their upwellers. Brine dip is how most of our people deal with fouling. So you make a saturated brine solution, which is just seawater, and then you just take a sack of salt, and you keep adding it till it doesn't dissolve anymore. And so you bring your oysters up. Let's say you have a cage of oysters. You bring it up and you bounce it around and you leave them in the air for a while to make sure that they all clamp up tight. And then you can drop them in a saturated brine solution for 10, 15 minutes. And what happens is the oysters, because they're clamped up, that doesn't seem to bother them. But all that other stuff, all those tunicates and stuff, that saturated brine solution kills them. And so then you leave them out and air dry them for a while after that. And it seems to help. Now, if you do this, first of all, do it to a very small amount of oysters first to make sure that it works okay. I had one guy kill a whole year's batch because he just threw everything in brine without playing around with it. And he did it right in the middle of August when everything was the hottest and the animals were the most stressed. He's not the smartest tool in the shed, the sharpest tool in the shed. So if you're going to do it, try a small sample first. Let them go for a couple of days. Make sure they all survive, and then you can scale up. Another way, this is one way that some folks have proposed dealing with those tunicates. Apparently, if you just take something like white vinegar and you spray it on your oysters, it will kill those small tunicate stages. And so if you do that regularly, like in your upweller or something, in theory, you can get rid of your mogula Just put it in a garden sprayer and spray things. And it's supposed to work almost instantaneously, so you can just spray it and then throw the animals right back in the water, and you won't get those tunicates growing. This is a big brine dipping system, so these guys, they're dipping their whole cage all at one time into a brine vat that they've got in this dedicated barge. And then they'll dip it in there for 15 minutes or so, and then they'll pull it out, and then they'll let it air dry. Sometimes they'll air dry them overnight and then put them back in the water after that. And that works okay. You probably have to do it a couple of times, at least at our end. We do it a couple of times a summer, generally sometime mid-July, and then maybe again in September sometime. Depends on water temperatures and those kinds of things. Some people have been playing around with hot water dips. I got this out of a Korean document, but basically you just take fairly hot water, and which the oysters will kill the oysters if you leave them in there for any extended period of time. But because they have such a heavy shell, they're more tolerant to a short immersion in hot water than some of that other soft-bodied invertebrates that are fouling. And so you can do a quick bar dip in a warm water system. So some people have been rigging it up. They have big boats. They just rig up their cooling system so it circulates through an outside tank. And lastly, probably the best and most effective way is just straight gear rotation. Just have an extra 25% bags. This is a program that we developed through our USDA agency up in Rhode Island. And they allowed each grower to have 25% extra gear. So you just bring your fouled bag in, transfer the oysters into a clean bag, throw the oysters back in the water, and then take the dirty bag home and either clean it or let it air dry. And then, so you're removing all of that organic material, and at the same time you're cleaning up your gear. And so I think I'll leave it at that. I don't need to talk about harvesting because,
We're just gonna grow them and not harvest them?
well, I think these guys probably know how to harvest. You pick up your bag and you dump it out on your culling table. Oh, actually, let's talk a little bit of, wait. No, there's one thing I do want to talk about. Grading and quality control. You really, as I mentioned earlier, when you're developing half-shell oysters, I don't know if you've been tracking the market, but it's literally a boutique market, and every single oyster, every single grower has done something to try to distinguish their oyster from everybody else's, whether it's a unique name. Mostly it's by naming. So we have moonstones, and we have matunics, and we have hog islands, and we have chesawonks, and we've got any of 1,000 different names. And the people that are eating oysters now recognize some of these names. And if you do marketing and branding properly, you actually can enhance the value of your product. But if you do that and you spend a lot of time trying to establish your brand, do not throw crap out there under that brand name because you're getting low on oysters. So you want to make sure that you grade and qualify your oysters and then sell them according to their value. And, so you may have 3 different names for your oysters, with your premium oysters having one name, so only the best go out there, and you get 10 cents an oyster more for those than you do the second grade, which may have a different name. So you got to think about how you market these things, and what you don't want to do is you don't want to throw crap out there under your primary name, because it's going to devalue the quality of the asking price that you can get for your oysters. So, always spend time grading and culling and cleaning and putting a good product out there on the market. And there are ways to do it. There are mechanical grading machines. And one last point is tumbling. When handling these oysters is a good thing. Because as I mentioned earlier with those flip bags, to get a really good shaped oyster, you have to control the growth rate of the shell, primarily length versus cup development. And so by tumbling them on a regular basis, you're knocking off that early length growth, and you're sort of forcing them into forming a deeper cup, which makes for a higher quality oyster. And so we have a lot of people that, 3-4 times a year, summer, will run their oysters through a tumbler, not just to clean them, but to actually physically break off some of that new growth so that the animal forms a better shape and forms a deeper cup. And so that will help you in terms of developing a good quality product for your farm. And I promise that's the last thing I'm going to say.
Thank you, Leslie. I'm Rick Hutchinson. I'm the administrator over the shellfish processing plants for the state of Florida. And I'm just here to briefly tell you that we have been mandated by the ISSC to have a harvester, and not just harvester, but for the processors and farmers training program, and we will be offering that starting this month. As far as the processors, it's part of the routine that we'll be doing as we come through with our inspection process. We've been approved since that is basically what we try to do during inspections, is provide training and opportunities to help you guys make a better product and a safer product to present to the public. So that's just an ongoing thing. We've been allowed to use our training process for that. With the Apalachicola Bay Oyster license, it's required to have a 20-minute sit-in with a videotape that we have developed. We're going to be giving, I think it's 2 days a week, two sessions a day, training for the harvesters there. And we are also offering it statewide as a favor to the FWCC to help them get all their harvesters statewide. And we will have them in different offices. I'm not sure about the locations, but it will be provided statewide for all harvesters and processors. And that's it.
All right, how about a 10-minute break or so?
All right, a couple housekeeping things. I'm Paul Zajac that Leslie talked about earlier. I do have copies of the first two workshops, the two different DVDs, so just catch me and I'll make sure you get them. We have a sign-in sheet in the back, and if you've not signed in before and you want to get a DVD of this workshop, make sure you put your name and address on there and write legibly, so that it'll get to you. It'll probably be 30, 45 days before, we're producing these all in-house, and so it takes us a little while to do that, but we'll mail out a DVD to everyone that's attended the prior workshops, and if you're new to this, put your name down and you'll get one for today. I was going to make just a few remarks. We've had people that are modifying existing leases to do off-bottom water column leases to raise oysters in the different gear that's been talked about in the prior workshops, either the floating gear or the suspended gear. And we're also having people that are applying for individual leases that are apart from these aquaculture use zones, like Alligator Harbor, which is the one up in here, or we have several aquaculture use zones down around Cedar Key. And so there's been these frequently asked questions. And so if you're of the group that's applying for an individual lease apart from those aquaculture use zones, then I just want to mention that you make an application, if you're interested in that, to the Division of Aquaculture. You're going to identify the location. You're going to describe to us the production gear that you're going to use. We will go out and do a site visit and then process that application going forward to the other agencies. There's interagency review on that application. Then if it meets all the thresholds and hurdles, then it goes before the governor and cabinet for their final approval. You're leasing a public resource, submerged lands that are owned by all the citizens of Florida. So there's a review process. There's a lot of questions that are raised, and you have to successfully complete that. And eventually, if you decide to do this route, you'll appear before the governor and cabinet, and they will, by that time, we're in pretty good shape. They'll approve the lease. So for those new leases, there has to be a survey done after that's approved. It has to be surveyed by a professional engineer, and that cost will have to be borne by the leaseholder. I'm mentioning this because these questions have been coming up. If the application fee for a new lease is $200, and the lease fees are different than the on-bottom leases. So this is again why this is coming up. It's $33.46 an acre, or any fraction thereof of an acre, and there's a $10 surcharge per acre, or every fraction of an acre thereof. And this is about double what the current on-bottom leases are. Still, in our minds, I think in most people's minds, this is still pretty reasonable, but that's what it is. And if you're going to use this surface running gear or the suspended gear, you're going to have to work with the Coast Guard, and we'll be glad to help you in getting a private aids to navigation to mark that lease as a hazard to navigation. A boater would collide with your gear. So the rules of the road is appropriately mark these leases. They have a certain signage type, a light requirement, so that the boater can be informed on the water, but it also changes all the navigation charts and identifies that lease as a navigation hazard. And there's a fact sheet on the back table there right behind you that talks about these navigation aids and how to apply for them and where to apply. So remember that the current on-bottom lease is only up to 6 inches. If you look at your lease agreement, if any leaseholders are here, you're allowed to use up to 6 inches. Anything over that 6 inches is considered a water column lease. So if you're planning to use some of this gear that has been talked about today and it's clearly more than 6 inches off the bottom, you're going to have to come in and get a modification to your existing lease to do that. Or if you're thinking about a new lease and want to use this gear, you're talking about a water column lease to do that. So any questions? Okay, very good. Now, if you have questions, it comes to you as you're going through these presentations, you can ask me, or Portia is here. Raise your hand, Portia. And she runs the program. So instead of talking to me and me saying, oh, go talk to Portia, just go to her and we'll be good. But remember these DVDs, please fill in a sign-in sheet. And we also put surveys out there. We are open to criticism. And here's a chance to fill in a survey, leave it here with us or mail it to us. Tell us how we did, what questions you'd like to have answered, maybe in a future workshop, or some question that never did get answered. And we'll get back to you, put a phone number, an email address. We'll get back to you and answer those questions. We really are open to this. We want to make this it's not easy to do, but make it as easy to go through as possible. So thank you, Leslie.
Thanks, Paul. If you would suit up Rick. But we do have one question for Dale. So Dale, just one. Modifying some of the gear that you just showed using wood. Have you used wood? Any of this gear, and is there any concern about using wood?
There's no concern. We actually have people
Pressurized, treated wood, yeah, obviously. Yeah.
I've used it. Rick had some people actually build a nursery system out of it.
Yeah, I'll talk a little bit about that.
Okay.
Because when we first,
So, yeah, it's not, there's enough flushing so that it's not an issue in terms
So none of the regulatory agencies have expressed concern about using that?
Copper sulfate treated pine?
The stuff that they use, I think, was CCA, which is it's chromic arsenate.
there's one grade that's not as toxic,
ACQ.
and you're allowed to use that.
ACQ grade?
I think it's ACQ.
Oyster, or
And you are allowed to use that? Yeah.
What grade was that again?
ACE.
ACQ, I think, is that what it is, Rick?
Thank you.
Is that copper sulfate?
I don't remember.
It's mostly copper-based, I believe.
Okay, let's introduce the next speaker, and we're going from Rhode Island to Massachusetts. Actually, we're going to Martha's Vineyard. And Rick Carney has been the director of the Martha's Vineyard Shellfish Group for over 30 years. Is that correct? Over 30 years.
76.
That's a not-for-profit organization comprised of all of the shellfish departments for all of the island towns, and they've been involved in it's a community-based resource management program. They've also worked on innovative aquaculture program and training programs for the folks there in Martha's Vineyard. He runs a solar-powered hatchery. I don't know if you're going to talk about that, but he's produced hundreds of shellfish seed, different species of shellfish, and also has been consulting throughout the world based on his expertise. All right.
Thank you, Leslie. Actually, Leslie asked me to speak a little bit about a training program we did actually in 1995 and 1996, pretty much with new growers, I guess similar to you folks. And where we are now, and maybe some of the issues we had to deal with along the way. So I have a lot of pictures. A lot of the stuff that Dale mentioned, he covered, but I'll touch on them a little bit, and maybe I have some pictures that maybe illustrate that stuff a little bit better. So we'll just move right into this. I just want to say that, I mean, if you can look at what we had to deal with, it's always been an us versus them kind of conflict, and I've kind of stuck the slides together to kind of use that as kind of a metaphor. Historically, as in most areas, there's a strong tradition of public common with wild fishery. In the 1950s, there were some attempts at some private aquaculture beds, and as soon as they became productive, the townspeople got up and said, oh, well, why should these guys have everything, and basically took the lease away. And in the 1960s, again, there were some people that were way ahead of their time and wanted to grow oysters and had plans, and they essentially were forced to move off the island, and they did it elsewhere. The way I came in 1976, and the towns kind of said, well, we want to keep it as a public fishery, but we kind of like aquaculture, but we don't want anybody having control over it. So you can do this, but do it publicly. And I pretty much have worked, the solar hatchery here is what Leslie mentioned. We built that in 1980, and we essentially produce scallop seed and clam seed, hard clam seed, and oyster seed that we essentially put into the private beds. And I'd been doing that for about 20 years, and a little bit frustrated because we produce about 20 million seed, and I work with the towns. Each of the towns, there's 6 towns on the island. Each town has a private shellfish, has a shellfish constable, rather, public shellfish department headed up by the shellfish constable, who essentially is the clam cop. And one of their jobs is also to do the propagation. So we would produce these millions of seed shellfish in the hatchery and then give them to the constable, and maybe he might have 1 or 2 people working for him in the summer, and ask them to take care of 20 million or 10 million seed or 5 million seed. And it's just, we didn't see the results because you need a lot of TLC to protect them from predators and all that stuff. So the time became right about 1995. The offshore fishing industry was in trouble because the beds were being overfished, and the federal government came up with some money and said, okay, there's a lot of fishermen out there. We've closed the beds. Find something to do. Find something else for them to do. And similar to what Leslie did when they closed the fishery here in Florida, she did a training program, and I was aware of that. And this program is really patterned after you were the inspiration for that, Leslie. So it's your fault too. But so in 1995, we started this private aquaculture initiative, and the idea was to turn local fishermen into growers. And the training involved some work inside where we had different speakers come, similar to a situation like this, and we took them on a lot of field trips. This was a particularly very cold day in February. We had a wind chill of about -20 out there, and they went to see, this was a quahog farm, a clam farm, and this really impressed them because within about less than 20 minutes, we were out on the flat, and the guy these were wild fishermen, went out there and got his limit in an hour, or less than an hour, and they were just amazed, and they were sold. So they wanted to do work with what we call them quahogs, hard-shell clams, and we found out that because we don't have, that shot that I just showed you, this is, again, in an area where there's a 7-8 foot tide, and these beds are, it's intertidal aquaculture, and it's pretty easy to work because you don't have much fouling. And quahogs, clams you have to have in the bottom. So if you don't have a big tide, we only have about a 2.5 foot tide. We don't have the exposure like this on low tide. So it'd be really difficult for the guys to work the bottom and protect the mesh. This way, the tide goes out, these things dry out a little bit, some of the fouling is kept down. So luckily, as the guys were working, I told them, I said, don't put all your eggs in one basket, try a couple different species. And one guy attempted to grow some oysters. And lo and behold, we had a really beautiful oyster, and everybody decided to grow oysters instead. So we became oyster farmers. Again, Martha's Vineyard is an island. One of the things, again, I don't want to get into too much about the lease conflicts because you obviously already have an area that's set aside, and Leslie's done all that work for you. But on the Vineyard, we had to work with the individual towns. There are 6 towns. And even today, 20 years after we started this program, only 3 of the towns really allow aquaculture. It's up to the individual town to decide whether they want to do it. And there's a lot of conflicts, but we basically work. And one of the concerns, I guess, that I should say right from the start is that they feel that these waters, they fished these waters for years and years and years, and they were afraid of private aquaculture. They were thinking of big shrimp farms, and some big corporation was going to come in and essentially take their bottom away. So that made them very nervous. And the idea was that to design a program that would be small enough that it would just be, you wouldn't have any big corporations coming in, and at the same time limit it to, you had to be a resident of the town to get a particular spot within that town. And it pretty much helped if you were already a commercial fisherman. So the idea was to keep it for the fishermen and to just have them, teach them to go the next step. So this is, well, let me just go back here just for a minute. This is Katema Bay. I'm going to talk about this area here. There's some aquaculture here, and the other area where we have some aquaculture is in Menemsha Pond here.
Show where you are.
Oh, and I have, my hatchery is here on Lagoon Pond, right about there. And we have a facility also on this side. There was a lobster hatchery on the island that kind of shut down, and we now lease that to expand our facility there. And on Chappaquiddick Island here, right about here, we have another nursery facility.
Rick, what's the average lease size on?
Oh, okay, the lease size, well, I'm going to get to that maybe in the next picture, but, well, I'll show you. These are the lease sites. When we did the training program, we helped them get some sites. And again, within the pond, these are the really prime areas, protected areas. They were allowed 1 acre here only. And then we kind of thought, well, maybe they're going to want to expand at some point. So this area out here, there wasn't as much conflict. I mean, there's a boat harbor here. There's, recreational boating, whatever. Not so much out here. So they have sites out here also. But what's happened is this area just it's not very protected. So in a good winter storm, it's really hard to keep anything here. But I'll get to it later. But what happened is we have a problem with Vibrio bacteria in this pond. They were shut down. And what a lot of the guys are thinking about, we've got guys that are, it's their bread and butter now. They're thinking they still have their leases out here, and they're trying to change their gear enough that allow them to get out here. So if these beds are closed, they can still pay their bills. So it's kind of nice to have a couple of sites. So that's kind of the original plan on the zoning. And this is Jack Blake. He was a quahog fisherman, a clam fisherman, really brilliant guy, and just a wonderful guy. Just shares all his information, and he is really responsible for making this a success. If he was a greedy person that didn't work with other people and share his ideas the way he did, this industry never would have gone anywhere. He's kept his operation small. He still grows. It's just he and his wife, and they grow about 200,000 oysters a year. But they're really beautiful, and he's got his own business, Sweet Neck Farm, and the oysters are pretty famous for their quality. And get you some idea. There's his logo and some of the oysters, rather.
So is that the Nestler tray?
Yeah, this is another grower. This is the stacking tray.
Yeah, those dark seas.
Dark sea, yeah. And what it is this, it nests, I have another picture of this, and then it basically can get hung here.
So, yeah, they hang off the center.
Yeah, but the problem is they're very expensive. If you've got a lot of money, maybe. I mean, things grow really well, but if you want to really gear up to big volume, it probably is not going to work. But I mean, in terms of compare this with the nest here, it's
just going to take more money.
Well, more money, and yeah, your bottom line's not going to work, I guess. But these are better than nest tiers. Obviously, as Dale said, there's more, there's less plastic solid, and there's better flow through these. No, they're a really nice system, only they're expensive. And you'll see what they use, and it. Just to go back a little bit, Jack's Oysters sell in some of the really top-notch restaurants on the island, $2.50 a piece. And Jack, he gets about $1, 95 cents to $1 for certain restaurants. He has the licenses, so he doesn't have to sell through a fish market. He can sell directly to a restaurant. And this is Jack here. This is one of our new growers, Ryan Smith, and this is his father, Joe Smith. And again, Jack was just such a neat person in terms of he shares all his information, and he's really brought this. He's like the godfather of the bay there. And it's interesting, this guy's a real traditional fisherman, and his son got into this business, and Joe is now working on the farm a lot with Ryan, and it's just really cool. And I didn't have the greatest pictures here, and the growers, they sell to off-island distributors, and part of the sale is that they sell individual, like branded varieties, and the buyers like to play up the idea that, and have almost like a little portfolio of know your oyster farmer kind of thing. So I was able to go online and kind of steal a lot of these really great pictures. They had a professional photographer come out and take these pictures because this is on the seller's website, and this is a story. So people want to eat these oysters because, they see the individuals that are behind the culture. And that's part of the selling of a branded product. This is another guy, Nick Turner. His are called Honeysuckle. This is actually, I think I stole this one from a Martha Stewart website. And he's listed on there. No, nobody has problems with dogs on boats in Massachusetts, I guess. But there actually is a fella on that has a kind of an oyster blog, and he ran a special thing, and he had dogs on oyster boats, and he asked all the growers to kind of send their pictures in because he thought it was such a neat thing. But okay, so this is a close-up of Katama Bay. I showed you where it was. The lease areas are in here, and like I said, they're 1 acre. We now have, there's 12 acre sites that are allowed. There are 11 active sites now. We're producing about 1.7 million oysters, market-sized oysters. The value is 1.06, or it might even be a little bit more than that, depending on who you talk to. The fishermen are getting 55 to 70 cents a piece on average. Like I said, if the Jack sells directly to the restaurants, sometimes I think he gets 90 cents, depending on the quality of the product. And this is information from Jack. Jack thinks that they're capable of doing about 3 million on the 12 acres that are available within the pond here. And then I'm going to show you some tidal-powered nurseries, and they're located in this area here. The water exchange is much stronger here, and the idea of these tidal upwells is to put them in a place where there's a strong current. They'll grow faster. So I'll show you some pictures of that. And one thing I also should point out that this is Barrier Beach here, and about 7 years ago, 6-7 years ago, it breached here, and it changed the whole environment for them. And they've had to deal with, this is open now, and Chappaquiddick is truly an island. But it migrates down, and the opening is about here now. And it migrates, and then it's going to seal up again. So it'll change things for them, but they've dealt with it. Okay, so just a little bit about, they deal with single oysters. And the idea is, you're going to get your best money for an oyster. The biggest market is on the half shell, so you want to have for raw bars. So everybody wants them single. Just quickly how they've grown. You usually, when an oyster larvae, when it gets ready to set, it looks for a hard surface to set on. Usually it would set on a shell. If you want to make a single oyster, you grind up either oyster shell, or we found that eggshell works about as well, and we sieve it to about 300 microns. And an oyster larva, when it gets ready to set, is about 25 microns. So that way only one oyster can fit on the shell, and you hope to get a single one per. And here's some shots. I took a 19-day-old larva. It's swimming around. This is the little pieces of eggshell. And here they're setting. There's an eye spot, and this one's actually attached, and right after they settle, they grow very quickly. And this is the same little eggshells, and you can see they get overgrown by these oysters at 23 days. And then once they're about 1 or 2 millimeters, when we're doing the training program, we actually provided the guys with oysters under this training program. Now they buy them from a private hatchery, but just to give you some idea, they would come and pick up their oysters, and then they would start the nursery process with about that size oyster. Okay, so once we've got the seed, it's basically a battle with predators. So you have to put them in some sort of cages, okay? And the early stages are in these tidal-powered nurseries. These stack, actually, I'll show you some other pictures of this. And then eventually they grow up to about this size, and then they move into what Dale talked about, rack and bag systems. And this is pretty much, this is Jack's design, but again, he shares his ideas, and this works pretty well. A little bit, it has to be welded up, but once it's built, they last pretty long. And Jack actually, because he has this design, he's so happy with them, he actually makes these out of stainless steel now. He welds the stainless steel because he figures, well, I don't want them rusting. This is an idea that works for me, and he makes them out of stainless. Other guys don't use quite that. Okay, so once you have the little seed, you have to put it in a nursery. There's these, have you talked to them at all about floating upweller systems?
Well, nobody up here
Has one.
has a nursery, land-based or floating.
Okay. Well, one way, you essentially have to protect these oysters, and they're really tiny, and if you put them in one of these really small mesh bags, it fouls really quickly, and it's really difficult. And if you can get them more flow, they're going to survive better, and they're going to grow better. So these kinds of systems have been developed. I'm not going to get into the particulars of this, but essentially, there's water pumped through these and the shellfish are in here, and this water is pumped through here very quickly. There's a pump here, and
does Andy still have a fluff seed? Actually, Andy still does.
yeah. And if you want them to grow really quickly, this is the way to do it. These are usually, because you need electricity, these are usually tied up to a dock somewhere. And one of the things that Dale alluded to, and I think is really important, all the growers tell me that if at any point the seed stunts, if you crowd it or stunt it, it takes a long time to get over it. So if you stress this seed out when it's really small, it's going to suffer for a while, and it's going to take a while to get out of it. So you just really have to be ready, and you want to just give them optimal conditions, especially when they're young. So because a flupsy doesn't work because these guys essentially, Martha's Vineyard, we're talking about the Kennedys, and the waterfront property is millions upon millions of dollars. So these guys don't, unless they're lucky enough to have inherited it or somehow, don't have really a home on the water. So they don't have access. They essentially, have their boat in the harbor, and they go out in the water, and they have to work out there. So the whole technology that they've developed, they can work out of the boats. So instead of using electrically powered flupsy, this is a design, a tidal flupsy, and essentially what it does is you'll see the pictures, but you tie it to a mooring, and it swings so that this is always catching the tide water. And because you got this big opening here and it narrows down, you collect all this water, and then it speeds the flow up and out. So it essentially captures water. That's kind of what it looks like in the water. Again, it's moored at one end, and it swings so that when except on a slack tide, there's no flow through it. But otherwise, it's always catching the water. And the more flow you get to the animals, for the most part, the faster they're going to grow. And again, they've got permission to put them actually in the area where most of the boats are moored. And again, this area is called the Narrows. It's an area that concentrates flow. And they've dressed them up. They've got little wash tables, little crane arrangements, even little fences to tie their boats to as they work on them. And you can see that they're basically the work areas, because they can't take the stuff to shore. If you look here, this is Chappaquiddick here, but there's some really expensive houses up here, and they don't really have shore access to work. Again, that shot from Jack has come up with this design where the seed is put in stacked trays, especially when they're small. They can have up to 3 different stacks, and the water is forced up through them and out. That's the only way that the water can get out. It has to go up and through the animals. That's the idea of an upflowing upweller. So this is, a lot of seed coming from, I don't know which grower this is, but they're buying their seed now from a private hatchery, mostly in Maine. That's what it looks like when it comes. And they put them in these little trays. That's Jack. There's a shot of them. They actually look a little bit bigger there, but this is to give you some idea on time schedule for us. June 1st, they get 1 millimeter seed. This is actually larger. They thin the seed every 8 to 10 days, so you have to really work with this all the time. You can see how fine mesh this is here. This is like window screen. So within like 2 or 3 days, this is so clogged. So they're almost out there daily, and they have to wash. They don't wash the oysters. They pressure wash the bins, but they don't wash the oysters because the oysters are so small. If you pressure wash them, you'd kill them. So they carefully take them out, and then they pressure wash the mesh. And then they grow very quickly in these systems. In 6 weeks, they grow to about 3/4 of an inch. And at that point, they get moved to cages, which I'll show you, and then they have to even start this air drying to kill some of the fouling organisms. Just a shot of Jack with the, and you can see this is a double stack tray here. About the question that came up about the wood, this, we actually made, when we did the first design, we were concerned, oh my God, you're going to have these little tiny animals in here. If we use pressure treated lumber, we might kill them. And we were even concerned about paints. So this was plastic wood, you know, the stuff that they use, that recycled plastic, and it weighs a ton. We burned out a gazillion drills, you know, machining it, and they basically use, they still don't like to use the pressure treated on the really tiny ones, but a lot of times they'll just use a painted wood surface. And it gets lowered in there. There's kind of a, I don't know if I think I can show you in this shot. Well, there's another one. So they're different designs, but they don't use the pressure treated wood anymore. I mean, the plastic rather. There's Jack, and they have to get rinsed and cleaned a lot. But they stack, and there's kind of this structure down here, and they just rest in these little slots. And again, the water's coming in, and the only way for it to go out, between here, we lose a little bit of water, but the water has to go through the animals to get through the upweller. Again,
How's that vessel being powered?
just by the tide. It's, you know, it's essentially catching the tide water and forcing the water up from the tides through the animal. So it's really neat. They can do that out on a mooring. They don't have to have any electricity. This is, again, a shot of, this is Tom Berry. He's not doing this anymore, but this is that system. And it pretty much, you know, well, here he was hanging it. But you need a float then to hang that off of. But so this is pretty much what they do. This is the rack and bag system. I think most of the guys on the island prefer the square box looking ones. And again, this is Jack's design for this rebar. A lot of the guys like that because it's a little bit more permanent, but you can buy, I think we've got a shot of that. This is kind of similar. Okay, this guy's got the triangular diamond mesh, and you can see it's pinched a little bit, but it's the same kind of technology there. This is the other thing. This is what's available. This is, again, the plastic-coated wire that they use for lobster traps, and these come as a kit, and all you have to do is they're all cut, and you just wire them, hong rig them together, and then the bags slide in them. And again, we only have a 2-foot tide, so one of the problems is the fouling. You can see the fouling that gets on these things. This is major for us. And you've got to pick the things up. We don't, you know, the tide doesn't, we don't have that 8-foot tide where it goes out and it can stay there. It has to come up. So they all have rigs to lift them. A lot of times if they're in muddy water, what they'll do is they'll pull them up and they'll actually run the boats and try to flush out some of the dirt that way. You can get some idea on the kind of vessels that they're using also. They're not, Carolina skiffs are really what everybody really likes. Yeah, wonderful vehicle, a boat. Here's Ryan Smith again with his arrangement, and Jack. And then they, you know, they have these little barges. A lot of times, sometimes it's just a work platform. Sometimes it's one of the flupsies, and they tie them up together and have their little operations right out there in the middle of this bay because they really don't have access to the shoreline. One of the guys was a big commercial fisherman on had a big offshore boat, and this is his design. So obviously you can see he's thinking about an offshore boat or something. But it's the same kind of thing. Here's a tank for brine dipping. Here's his cages.
So in the heat of the summer up there, what's your average water temperature?
Water temperature probably, I mean, we get 25, 26. Oh, Celsius. Help me, Dale.
75 to 80.
75 to 80, yeah.
At the surface.
Yeah,
At
yeah,
the bottom is probably closer to 70.
yeah. We don't get, it doesn't get,
Well, fouling.
fouling is a real problem. Oh yeah, you'll see this fouling. Okay, here we go. So again, when we first built these things, everybody was concerned, oh my God, we're not going to use pressure treated lumber. We're not going to use any bottom paint. But I think, I don't know, maybe we did use pressure treated lumber, but no bottom paint. So Jack, they had this idea of, well, let's tack plastic sheeting around it and let the fouling get on that. So here's at the end, I don't think this is even through a full season, and they brought it up to one of the boat yards and pulled it out of the water, and this is a sheet of plastic with mostly those sea squirts, but what a mess it is. And now they paint them with copper-based paint, and the oysters are fine. Yeah, this was a little bit of a nightmare. So again, pressure-treated lumber, bottom paints.
For your land-based, for your floating nursery.
For the floating nurseries, yeah. And then this is Jack Blake. Again, he's the guru. His overriding principle, he just says, really get them when they're small. Once they get some size to them, if you don't catch them early, then it's just a nightmare. And then also, there's a big learning curve on all this stuff, on how long you dry them, how long you dip them, what you do to them, how you spray them. And, he killed 70,000 in the process of kind of figuring this out. And, I'm sharing this information with you, but this isn't something, it may not work in your spot. You're going to have to always play around with little mounts and see what works. So this is essentially how they deal with it. They have air drying, brining, tumbling, and pressure washing. I'll show you another picture of this, but this is a tumbler that Jack developed, and he actually has a little air generator here that stores electric energy in a battery that allows him to operate this. And here's one of the big mansions in the background. I kind of like this shot because here we have, all these wealthy people here, and the actual average guys working there, and they get along. And I'll talk a little bit about how that happens. Okay, so this, not to get too involved in this, but this is Jack's the pressure washing used to clean the gear. When the nursery bins, you have, like I said before, you have to take the seed out. You don't want to spray the little seed with a heavy spray of water. And it's to get the muck out of the market oysters. Can be used to remove barnacles, the jingle shells and slipper shells. And you got to be careful about how you operate it. If it's too strong, you can kill the oysters, as you can do with anything else. Air drying seems to be what they like the best. Basically, you can pull it out and let it be exposed to the air. And most of these critters don't have shells. They don't close up. They dry up. The sea squirts in particular don't like to be intertidal, don't like to be out of water. But again, you want to do it often enough that they don't get too big. So again, air drying is the best. 1 day in the sun usually kills the sponge, the jingles, and the slippers. About every 6 weeks they try to do it, again, depending on weather. At 80 degrees Fahrenheit, they rotate the bags after 12 hours. After 24, 36. No air drying when it's over 90 or below 28. That's what they found, at least for our area. Again, another way to deal with this is just don't do rack and bag and do these floating bags. And when you have something like this, you can just flip the bag and you keep the mesh pretty clean. You can still get a lot of fouling on your organism because they're not totally out of the water. But there's a lot of reasons why this doesn't work for a lot of people. And in an area like Martha's Vineyard where nobody wants to see your farm, if it's underwater, they're much happier. If it's floating like this, it's an eyesore. Okay, brining. You want to be really careful about brining. Imprecise, unpredictable. Basically, Jack says use only when air drying is not an option. expect at least a 1 to 5% loss in your oysters. As Dale had alluded, make sure your oysters are closed. Shake them, or have them out of water for 15 minutes. Because if the salt gets into the only thing that's protecting that oyster from the brine is the fact that it's shut down. And dip for 1 minute. Air dry no more than 2 hours. And then he found do not brine dip when the water temperatures are warmer when they're spawning, because they're weaker and they don't tend to maybe close as tightly. So for us, between August 1st and September 15th, they don't recommend.
You'll notice that's different from what I told you, which is what.
Yeah, so it's going to.
What our guys do down in Rhode Island, so you got to figure out what works for you.
Exactly. And then the brining, you want to be really careful about the solution. They use a 60 to 80% salt solution. The salt has to be totally dissolved, not granular. Again, it's faster than air drying. You can kill 80% of the fouling, 100% of the sponges and the sea grapes, 95, but you can also kill a lot of oysters if you're not careful. And then another way to deal with the fouling is this tumbling. And Jack's come up with this. This is one of his inventions. Again, like I said, he gathers the energy from a wind turbine, has a battery down here. This thing works. And the thing is, you can't just, if you tumble them dry, you can really do a lot of damage on them. If you just want to, knock some of the barnacles off, he basically has a trap door here, and he gets this about maybe half submerged in the water. So they're cushioned a little bit. And then by doing this and seeing how many he's killed, he's eventually figured out a way that works for him. And then as Dale mentioned, it also not only cleans the barnacles off, you can actually get rid of 6mm barnacles, but you can also kill 20% of the oysters if you're not careful. Again, tumbling dry, you have to be careful about. This, and it cleans things, and it also, as Dale said, removes kind of the edges off of the oysters and then creates that deep cupped oyster that'll give you the better price. And then, obviously, Jack has shared his information. Here's another reiteration of that, probably very similar. You can see he's got it, Ryan's got this in, half submerged in the water, but he's got it out of a plastic drum rather than, I think Jack loves stainless steel rather than the stainless steel. But here he is, he's, essentially emptying his bag right in there, tumbling it, and then it goes up on the culling board here, and they work with it. And there's the bags getting ready to go. Okay, so now the other problem is this question of how do we all get along? We've got like water and everybody wants to use it, and how do you make room for aquaculture? And it's a really touchy thing here. I don't know, how many people from away you have here that, basically move here and want to tell you how to do everything, but we have a lot of it there. So the idea is, and these people have a lot more money than you, so you're not going to fight them because they'll take you to court and you'll lose. So you want to get along with them. And basically we're dealing with, we've got the aquaculture growers who are the new kids on the block. We've got the wild capture fishermen who have been here for a while. So they're kind of, there's some friction there. And then you got the riparian landowners who essentially buy a property, they have more money than God, and expect that they own everything in front of them. So how do we get these people all get along? Okay, so obviously there's regulations, there's zoning in terms of where you put these things. Sandy's going to talk about best management practices. And then what's really important is good neighbor etiquette. And then we have helped with some education and public relations and promotion to let everybody know what the industry is about. Again, good neighbor etiquette. The guys actually will share some of their oysters. They'll drop some oysters off on some rich person's dock to share. They cooperate, and again, there's mutual respect. A lot of these guys come from the fishing community, so they know the fishermen, and they know each other. They can get along, and there's always and essentially, like I said, it's kindergarten skills. We should have learned them back then, and there's a reason why they teach you that at an early stage. Okay, so again, the farmers versus the homeowners. Again, being a good neighbor, but also we need to do this public relations campaign. This is a woman, actually. We do this. There's this big dinner, And these people get dolled up, and this woman's like nuts about oysters on the half shell, and she comes with her special jewelry. There's this event called Taste of the Vineyard, and it happens in June, middle of June, just as our tourist season begins. And it's a big like a public wedding. People pay $125 to come and get a ticket, and all of the restaurants, since the beginning of the season, they offer their dish that they're going to serve for the season, and there's lots of alcohol, and it's like a big wedding. And the thing that is neat from our standpoint is that many of these, it's one of those high society events, so a lot of people that live around the water come to this. And I took it as, well, we had two things we were trying to do here. One, we wanted to kind of introduce this product, because when we had, the guys had the cultured oysters, the local markets, you know, these guys wanted more money. The local oysters they were paying 20 cents for, and these guys wanted 40 cents. They needed 40 cents to do what they were going to do. And the market said, why should I pay 40 cents for your oysters when I can get wild ones for 20? And we kept on saying, well, it's a different product, it's a different product. So then we did this marketing campaign, and people came to these events, saw this, and said, oh my God, these are wonderful. Where can we get them? And we said, you go to the fish market and ask for them. So after a while now, the fish market's got a board up, and they've got all the different brands. So, but you have to work at it. But also, what we do is usually, I do some shucking, but usually I'm on the side here, and I'm talking to them. And they come up, and they're a little tipsy, and I say, isn't this great that this is grown in your backyard? I know. I do shuck a little bit. But essentially, I mean, you want people to feel that they have ownership of this, that this is not some ugly thing that's happening in front of their mansion, that they should be proud of the fact that this wonderful product is being grown in their backyard, because they feel it's their backyard, even if they don't own it. So you have to work with them, again, and it's PR. We've been doing this for 20 years. Here I am, I'm still doing it. We do it once a year. We also are in the paper and in the magazines as much as possible, make sure we get good press. There are brochures that we put out that are put out by the National East Coast Shellfish Growers Association, by the county people in Barnstable County on Cape Cod. And again, the idea is that you really have to educate the public about what you're doing, or they're going to fight you. You got to get them on your side. We do exhibits. We've even gone so far as to have bumper stickers. Again, the fact that there's no doubt about it, aquaculture, shellfish, it's good for the environment. We're the good guys, so let people know. And then we even, for a number of years, we did this aquaculture tour where we kind of got together with one of the boat launches in the area, and the fishermen were available at certain periods of time. They were at their barge, and people came out, and we couldn't, the health regulations didn't allow us to sell anything, but they could at least find out who the fisherman was, and then they could go to the market and buy his product. And we still do this. This was last fall. We had a big fundraiser and a kind of the beds were closed from Vibrio, and we wanted to kind of tell everybody it's safe to eat the oysters again. So we did this PR, and we just did another one for what we call by Valentine's Day, which was around. But again, you have to keep up. Okay, so, but you can do all these good things, and then you can do one thing bad, or one of the growers can do one thing bad, and you can lose a lot of PR in a hurry. This was a big farm that was located in Menemsha Pond, a floating bag one, which kind of, you can see it's pretty visual. And there's what it looked like from the sky. It was a huge farm, and floating bags. And it was running all right. It was good. Because the guy that was in charge was kind of making sure that everybody that lived on the shore here, they made a path so they could get their dinghies out to their sailboats and whatever else. There was a little bit of friction, but he worked on it. And then when he left, they didn't do it anymore. And what happened was stuff started washing up on the beach like this. And this is what you don't want to see happen. And then when I go around preaching about how wonderful and green aquaculture is, people say, well, what about this? What about this? So you want to be really careful that this kind of thing doesn't happen. And that's one of the problems with the floating gear, is that it has much more of a potential of being like this, and it's been a problem in our area. Okay, so some of the other things we have to deal with this Vibrio closure. We had Vibrio parahemolyticus. We had a couple people get sick. And this is the growers now. We've got a substantial amount of people. It's a $1.1 million industry. And a lot of young people in this. I mean, they've got families. This was a really heavy-duty meeting, and it was a tough situation for them. You can see how serious they are. But the fact that they're worth that amount of money now, we had the state legislators there. Everybody's kind of listening to them because they're not just one person. So, and these guys actually haven't been organized in an association. One of the things that came out of this is that, we ought to get organized so that when something like this happens, we have a little bit more clout to get what we want. And then I just want to end with one of the things that, you can see there's a lot involved in this. Somebody who doesn't want to expend a lot of money, another way to grow oysters, kind of get your foot in the door with aquaculture, is to plant spat on shell. And you can usually buy eyed larvae for relatively cheap from a hatchery. And then in a very simple setup, you can see here we just have a couple of tanks, old tanks. This is actually right on the shoreline, but you could do it if you pretty close to the water. You could do it at home. Bring some salt water in, put it in the tanks, and then this is the eyed larvae as it comes from the hatchery. It's on a fine mesh. There's probably there's a 500,000 seed there. And then this is the way we put it, we basically use a dropper and just spread them over the shell, aerate this water for a couple of days, not even a week. These settle down and settle onto the shell. You can see them there. Sometimes you can nursery culture them a little bit till they get a little size to them. And you essentially have this kind of thing where you have the oysters on the shell. This is way more than you would want to have. But then you just plant the shell out and on your lease, and if you have control of your lease, it's essentially one step above a wild fishery, but you can kind of get your feet wet with it. And one thing nice about this, if they are attached to a shell, they have a little bit more protection from crabs. So the crab has a rough time. If it's a single, it can just pick it up like a chip and eat it. These, it's kind of hard for them to get at. So the fact that they're on a big piece of shell helps. And just again, I think it's really neat that we have this fishing, this guy represents the fishing tradition. He's the father. There's his son. He knows that there isn't much future in the wild fishery. So he's gone into this and he's kind of brought his father along. So his father understands now. And there's Ryan with his new kids. And, hopefully this is going to continue. Thanks.
Let's finish up with the last speaker. We're still in the Cape Cod. And now we're with Sandy McFarland. And Sandy was a shellfish biologist for the town of Orleans and ran a small hatchery for stocking, natural fisheries. She may talk about that a little bit. And then also was the town of Orleans' first conservation officer. What am I doing wrong? Oh, I'm not paying attention. And upon retiring, actually wrote about her experiences in a book called Rowing Forward, Looking Backwards, Forward. And also operates a private consulting business, coastal resource specialist, and as there were two of them.
No, is that the first slide?
I hope so. Let me see.
She's confused.
So she's going to, oh, I'm sorry. Look the same.
I know they do.
So, along with several other partners, she is working with the East Coast Shell. I don't know why I keep doing this. This is ridiculous. I can't do two things at once. So she's working on a couple of projects being funded through the East Coast Shellfish Growers Association, and she's going to talk to you about that. So forward, and there's laser there.
Okay.
Are you on?
Am I on? Okay, thanks. Thanks, Leslie. I'm not going to take up too much time. I know everybody's a little tired after all of our talking a lot about this. I just wanted to say that Leslie's right. I did work for the town of Orleans, a small municipality. What Rick didn't say was that each municipality manages their own shellfish resources under broad guidelines by the state in Massachusetts. It's pretty much an odd system, as everybody thinks, but it does put it on a real local level. I worked for Orleans. I did grow shellfish. I managed shellfish. I did the management and propagation for the town. I was in the regulatory structure, making the regulations, enforcing the regulations. And then when I left shellfish, I went to the land side of things. And I went into the conservation, where I was working with the Conservation Commission, and realized that my focus has always been shellfish. It hasn't wavered one iota. But to save the shellfish in the estuaries where they live, I realized that I had to be on the land side of things and try to help the estuaries from that perspective. So as things sort of went along, I stayed with conservation for a while, and then I did retire early. And I got involved in projects like best management practices. And that is a whole different side of things. That's still with the shellfish, but it sort of takes into consideration some of the things that Rick was talking about, which is the conflicts of use. So I did worked with these partners, Jeff Flimlin, who lives in New Jersey, and Ed and Kathy Rhodes, who at the time were in Connecticut and Maryland and have now moved to Key West. And then we developed, the four of us developed a manual for best management practices for the whole East Coast of the United States. And then we took that a step further, minus Ed, and Jeff, Kathy, and I worked on another project just recently to have a proactive approach of how best management practices can be used effectively for individual growers. So the industry on the East Coast is, and I was trying to get the updated information from Skid. He mentioned this yesterday at one of the workshops. So this isn't quite up to date, but it's close enough for our work today anyway. It's worth $100 million on the East Coast. There's 1,000 farms, but most of them are small. Most of them are mine power operations. They have less than 10 employees, and they're basically in very small leases. In all states except for Delaware, only Delaware is just now getting into aquaculture. We did one of our workshops in Delaware, and there were a lot of people who are getting ready to have their own farms on farm leases. In most states, you are leasing public bottom. I know Paul talked about that when he was talking to you about what you're doing. There are a few states that have deeded rights to the water. They go back to King's grants years and years and years ago. But in most cases, it's leased public ground. And because it's leased public ground, it means that you are paying the state to do what you do. But it also means that everybody and his uncle is watching what you're doing because it's public. So the industry consists of all these different species, clams, oysters, both hard and soft clams, and as Rick said, we call them quahogs. I'm sorry, I will never budge from that. Mussels and scallops. For the process for the first part of this, getting the BMP manual, we held 20 workshops throughout the East Coast. We did come to Florida. We came to Florida twice. We went to all 11 states, and each time we went twice. There were over 300 participants in this program. You can see 200 in the first and 100 in the second. The first part was to get at what the issues were, and then the second part was we came up with the BMPs and then to see whether we were on the right track. As we were doing the workshops, we realized that it came down to basically four main topic areas. Is the gear operation and maintenance, user conflicts, permitting and siting, which you just heard about earlier, and environmental problems. The results were a code of conduct, and the code of conduct is basically an overriding set of principles that was first established by the United Nations Food and Agriculture Organization, and they had a code of conduct for responsible fisheries. And we took that code of conduct and adapted it for shellfish. And it is basically things that you would normally do. It's sort of apple pie and motherhood, that if you're on the water, you should be doing these anyway, and most people are doing them anyway. But these are some of the ones that come out, obey all laws and get all permits. I mean, that's, pro forma, you got to do that anyway. But what Rick was talking about is communicate openly with neighbors. Make sure that you know what you're doing and that you're communicating that to other people who are using the waters. And minimizing environmental impacts. even though we are a green industry, there are things that can happen, and Rick showed one picture of the gear going aground. There are things that can happen that's not quite environmentally sensitive, so you got to be careful of those. But one of the things was to ensure economic and social sustainability. That is an overriding principle, as that's why you're in business, and to try and maintain that. Encourage other growers to adopt a code of conduct is also in there. You can read the rest of them. So what basically does the manual contain? Well, it's a description of methods, as we're talking about all these different species. There's all the different methods that you've heard about today. And although because this is a huge area we're talking about, it's the whole east coast of the United States, we assumed that it was going to be very, very different from place to place. And in some respects it is. And in some respects there is a lot of site specificity. But in a lot of cases, there are overlapping things that are going on in this industry far and wide. And so it wasn't necessarily as site specific as we thought it was going to be. The citing of the biological and social part of citing is really important, and Dale brought that up. And I'm using one of my own pictures, an aerial view of an area that Orleans set aside, and as far as I know, we were the first place in Massachusetts to actually set aside an area for shellfish aquaculture development, private shellfish aquaculture development. Up until that time, it was piecemeal. Somebody would find a site that they thought might be appropriate. They'd go to the town, say, can I have a lease here? And they'd go through this big, huge hearing process, and it was either thumbs up or thumbs down, and it was a big mess. And I looked at this and said, if we take this area and we set it aside, then we can get all of these things out on the table at the beginning, and a lot of the issues that come up, we might have that squared away. And it took about 2 years to get it through, and the people that were most against it at the time, this is back in the 80s, were wild fishermen. So, go figure. And anyway, Rick talked also about good neighbor policy. That is part of the BMP manual now. It's not something that we're saying is it is a benefit to make sure that you are a good neighbor. That if you have noise or smell part of your operation, and we take noise as for instance, if you've got a lot of summer neighbors nearby, they may not want to hear engines roaring at 5:30 in the morning. So be a little bit more considerate to them. But there are so many different activities on the water, and as I said, everybody's uncle's watching you what you're doing. But we also have our favorite, not in my backyard, folks. And most of the East Coast is most of the areas where the leases are on the East Coast. In some states there are some differences, are in places where there are other users. And the not in my backyard is a really big problem. And the more you can talk to your neighbor and get them on your side and see what you're doing, and Rick gave a lot of good examples of how you can do that, the better off you're going to be, and certainly the better off the industry is going to be. Seed sourcing in genetics is one of the BMP groups of where the seed is coming from and the source in genetics. And I know Leslie said that your regulations are actually BMPs, and I didn't want to indicate any differently, that yours is a regulatory structure, where the BMPs, which is a lot of them I'm talking about here, are in a regulatory structure. In the rest of the states, it is a voluntary thing that you're doing as part of best management practices. But we're thinking that maybe you can look at that a little differently when I get to that point. So the operation and maintenance, those are the things that Rick and Dale have both been talking about, both on hatcheries, onshore, and in-water nurseries. Things that you should be doing as good husbandry are actually part of the BMPs too. And so if you're following BMPs, you should be doing the things that you would normally want to do anyway. So the nurseries and grow out areas, fouling control, we've heard a lot about that. Siltation, gear disposal, we haven't heard much about the gear disposal, but that's an important part too. If you've got a recycling area at your disposal, wherever you take your dump, your trash, then use it so that this stuff gets recycled. So the manual has reporting and handling disease. It's something that nobody really wants to do, but it's really important to do it. Shellfish sanitation, so you don't get closed down, and record keeping is a really important part of this as well. Okay, all of this is in the East Coast Shellfish Growers website. It's in a manual. It is there for you to have. If you want a hard copy, you can get in touch with any of us, and we can get you a hard copy. But it is there, right there in black and white on the ECSGA website, so it's available.
You even have Florida clam farmers on that cover.
Oh, there you go. That's right. Okay, so we wanted to take this one step further. The four of us on these road trips, we're sitting in the car and we're talking about things. We said, this is really good. We got this BMP manual and we think that this is really important for the growers, but it's really something that might just sort of sit on a shelf. So what can we do about it? Well, we decided that a way of getting this out to growers to have them use it differently is to develop individual farm management plans. And in this case, what does that entail? Well, it's contact information. That's sort of first and foremost, and where it's located and all that kind of stuff. But then it goes further. And we're looking at using the BMPs and incorporating the BMPs into an individual plan that can be customized for your particular farm. And so, just as a for instance, we've got what are you culturing? And some of the BMPs would be that you're using disease-free stock as a for instance, or that you're using local hatcheries whenever possible, that you're not going outside your geographic range, though that you might be selecting fast growers. Any one of these could be a BMP. Or the gear maintenance, what we talked about, what Dale and Rick talked about, of how you deal with all of this gear that you have in the water. And one of them would be a really simple one, is that you check the gear regularly to make sure that the integrity is intact. I mean, you don't want predators any more than anybody. So, I mean, it's your loss if you get them in there. So you're going to be checking the gear anyway. Well, it's part of the husbandry. Or motorboat use, that you use approved, environmentally safe bottom paint. You're not using TBT or even copper bottom paint. That you're trying to be really environmentally conscious. That you have oil absorbent materials on your boat just in case there is a problem. Well, the plan should also be flexible. We're looking at it so that you can be changed as you need to do things. And so that you're developing this for yourself. It's not for anybody else. This is not part of a regulatory structure. This is definitely something that you want to do. Well, we're looking at the people who funded this project are risk management education folks from the USDA. And they're looking at risk management in a slightly different way. They have this risk management education arm, and they do funding for people like Leslie and all of the extension agents and programs, and they fund different things through USDA. But how do the BMPs demonstrate environmental protection? How is this all working? Well, you are normally paying attention to what you're doing. I mean, that's how you're going to be making money at this. And because you're growing shellfish, you need clean water in order to operate safely and for the public health. And so following the BMPs helps you do that as well. Well, what are the risks of shellfish aquaculture? We've already been through some of them. Weather is a biggie. Whether it's storms down here or ice where I come from, it still is a huge thing. And we've just mentioned the multiple uses of the waterways and boating accidents. But there's also disease outbreaks, both disease of the shellfish and disease to humans. There's threats to public health. There's mortalities for non-obvious reasons. Dale was talking about things that can happen and you notice things dying. Sometimes it might be from things like overcrowding, things that you've done in poor husbandry, but sometimes you just have no idea why they died. And like I said, our favorite NIMBY. Well, how do the BMPs reduce the risk. Sorry about that. We know predation problem. The BMPs say that you use the cages. I mean, it's simple. You use some sort of predator control, or otherwise you wouldn't be in business. And when the predators are found, you get rid of them, and that you inspect the gear often. They're very simple. They're very intuitive. They're things that you'd be doing anyway. But there's another one, and that is avoiding risk for other things that can happen. When you get hit by a red tide, as a for instance, or a sewage spill, or in your case, an oil spill, or you get Vibrio, any of those things can shut you down like that, because it's the state requirement that they have to shut you down. And when that happens, you've got nowhere to go. You've got nothing. There's no way that you can do anything about it. But the BMPs are at least showing that you're complying with all the applicable state regulations, that you're doing everything that you can to avoid that risk, that you're getting your shellfish cooled down as soon as possible. And the last one is pretty counterintuitive, but it is that you're reporting any suspicious incident to the authorities. I mean, human nature is that you want to stick your head in the sand and it's going to go away. And, you see something wrong and you say, if I just hold off, I'm just not, I don't see what I'm thinking I'm saying. I don't see it. But in reality, the sooner it's reported, the sooner the state authorities can address it, and hopefully the sooner you can get back open again. But according to USDA, they have a different way of looking at risk management. There's other risks that they think of. The first one, production, that's what we've been talking about. All three of us have been talking about that all afternoon. But there's also a price risk. We might have a sudden market change. There might be a flood in the market, or there might be something that happens that is the opposite that changes things. There might be seasonal fluctuations that you're not taking into consideration. There's a financial risk. And Dale was talking about making sure that you had enough bags so that you can split things up, that you can start to thin things up. Well, what if you don't have the financial wherewithal? What if you hadn't thought of this and you hadn't planned for this financially, and you don't have the ability to buy that gear? That's actually a financial risk. There's also a legal risk. If there are people who are challenging you, some of these people that are living on the shoreline in these multi-million-dollar houses that don't like you in front of their house, they may be taking you to court, and that can be a really problem with a legal risk. So you know that the loss of shell stock is a risk. You know that the BMPs are a tool that can help you avoid that risk. And some of the BMPs are something like the predator control, cleaning of the gear, etc. So where does that leave you? If you've got the BMPs and everything is working in that, well, isn't that enough? Well, the BMP manual is really just a document that can sit on a shelf once it's completed. That nice picture that we showed you, the cover of the document, we got the document, but if it's not used to your advantage and everybody else's, then it's just something that sits on the shelf. So we think that you can incorporate that into your company's operation to be effective. And there is expensive third-party certification that is on the horizon. It's being done with other fisheries. It's in the works in some quarters for shellfish aquaculture. With the small operations that are part of the East Coast scene, we don't think that most people are going to be able to afford to do third-party certification. And if you can't sell your product because you're not certified, if that ever comes, then you're in trouble. So is there a better way than the certification? Well, we think so. We think that the farm management plan might be it. The farm management plan is basically an operations manual, and it documents how you run your farm. It may ensure that your employees follow your lead, that they're doing everything that you say that you want done. It proves your intentions to potential lenders. Don't forget them, that you need to go to banks once in a while to get some money. And if you can show them that you're following a BMP program, in your state, yes, it is mandatory because it's regulatory. But if you can think outside that box and think, well, these BMPs are actually something that I can use to my advantage in marketing and getting money, possibly insurance, then maybe you have a leg up on these things. And it will help minimize the risk if you're using them. So we're going from we have a template on the website. It's based on an Excel file. It's easy to use. It incorporates the BMPs into a customized basis for your particular farm operations. That's basically what this management plan is. We think that to do this, it sets a good example for the local industry. It allows each individual grower to use the code of conduct and the individual management system as a marketing tool to improve sales. It may not increase your price. It may increase the volume. We're not really sure about that. But it may allow access to more markets. All of these things are possible with this kind of a thing. And we talked a lot about branding. This could also help enhance the branding. And it may separate your product from others or do it cooperatively. If you do it individually, it's taking the entity of somebody else and not forcing it down your throat. Jeff is really a real spokesperson on not looking forward to third-party certification. And so he really is strong on thinking that this is one way of sort of stopping that where it starts. But it also proves to the non-government organizations, regulators, and the dealers and customers that you're farming in an environmentally responsible manner, that this is what you're doing, and that you're doing it all for yourself. So putting this all together, we're starting with a code of conduct as an overriding principle. Goes down to the best management practices, like which in Florida is regulatory, and other states it's voluntary. That brings it down to risk mitigation. We are trying to mitigate the risk inherent in shellfish aquaculture. That brings it down to an individual farm management plan, which gives increased awareness for dealers, for consumers, and no need for third-party certification, and potentially increases sales, although we don't know this. Whoops, sorry. And stay tuned. We've done these workshops for the Northeast to do the farm management plan, and we've got a lot more on those workshops than what I've talked about today. We're hoping to get funded for the Southeast region, and if we do, we will be in Florida hopefully sometime next year. So, thank you.
So this was an opportunity to give you a look at what is going on in the Northeast in terms of oyster aquaculture. Couldn't think of any better three people to give you that look, so let's thank them one more time. There was a lot of information that they gave to you today. It's 5 o'clock. We said we would end. I know Paul wants to speak to you, but we're staying here tonight, so if you want to hang around and ask any questions specifically to these folks, we're here.
Okay, I just wanted to make sure everybody doesn't get a little confused by the use of the similar terms.
No.
Sandy, this is a great program by the East Coast Shellfish Growers Association, but the background to where we are in Florida is that each state is a sovereign state. We're a republic of states in the United States. So each state has had a different approach to their environmental regulations. Florida has one of the most onerous or restrictive, or however you want to phrase it, protective environmental programs of any state in the country, and for sure in the Southeast. So we have a U.S. Clean Water Act. Those responsibilities have been delegated to the states over time. Florida became a delegated state in the early 90s. That phrase, best management practices, that we use in our program with the Division of Aquaculture is actually a defined term within the Clean Water Act. And so in Florida, in bringing its regulations forward, initially said, we don't want to have the delegated responsibility because our regulations are actually tougher than what are in the Clean Water Act right now. And the state actually fought that for a number of years, said we're not going to become a delegated state. But eventually it did occur. There was agreement to do that. And your best management practices through our agency are actually an extension of the Clean Water Act down to these farms. And then in a lot of other states, the Clean Water Act is not applied to shellfish farming, but in Florida it is. So we have a very specific meaning to the best management practices. They're much more thorough. You'll see some overlap in what Sandy talked about, and that's a great thing. There's no argument with us. A little concerned about the use of the same term because it can confuse growers. But please don't get the BMP terms confused. that your lease agreement with the state is very specific, and our program and the Aquaculture Certificate of Registration is also very specific, and it is a regulatory program. You'll see some similarities, certain things that she talked about, the good neighbor, working with those kind of folks, communicating that you are a good environmental steward. Those are very positive aspects of the program. Certain things that we can't get in directly involved in, but we can talk to anybody in the public or any other agencies and say, this is the regulations of Florida, this is how we operate here, these are where our farms are in compliance. So we have sort of a similar problem with the Global Aquaculture Alliance. They use best aquaculture practices. And it further confuses people, you know, who are we talking to, what are they talking about? So hopefully in understanding that, you can be clear to others as well. This is a good program, there's no doubt about it. Good intents, good people working on it. But it's got this similar title. So just wanted to make sure everybody was on the
Is
same
there a
page.
book with the Florida best practices?
Absolutely. Yes, ma'am. You should have
Yeah.
a copy, actually.
Okay.
Well, you don't get a copy with your AQ card, so people do not know about it. All right, thank you all. Lights on, let's go.